Good morning, everyone. On behalf of the ISO, I'd like to welcome you to today's Resource Adequacy Modeling and Program Design Year-End Showings Assessment to review modeling and preliminary results. My name is Christina Guimera, representing ISO Stakeholder Affairs, and I will be facilitating today's meeting. Today's slide deck presentation is available on the initiative webpage, and you can get to that page by going to kaiso.com, and then under the Stakeholder Center tab on the homepage, you'll see policy initiatives. If you click that link, it'll take you out to our main initiative landing page where you can search for the initiative webpage. Next slide, please. This meeting is being recorded and the video file will be posted to the initiative webpage for information and convenience purposes only. The recordings and any related transcriptions should not be reprinted without the ISO's permission. If you need any technical assistance at any point during the meeting, please send a chat to Inteller Events, the host. Next slide, please. To ask questions during the meeting, you can open the participant and chat panels on the bottom right, and you can then raise your hand by selecting the raise hand icon at the bottom of your WebEx screen. Or if you joined audio only, please press *3 on your device. For everyone joining us today, please state your name and affiliation first before speaking, and you may also send comments and questions via chat to all panelists or to me directly. Next slide, please. Today's agenda will include an overview of the Working Group Policy Initiative context by Ansel Lundberg, followed by opening comments by Aditya Jayam Pravakar. At 10:30, we will have a short break before launching into a resource adequacy overview by Mark Kutstra. Afterwards, Sai Coppola will lead a year-ahead assessment on inputs, assumptions, and study design. We'll then take a break from 12 to 1. After lunch, Sai Coppola will take us into a year-ahead assessment on modeled scenarios. Then following that, Shuping Lee and Sai Coppola will discuss year-ahead assessment on deterministic results and probabilistic results. Then Mike Wu will discuss midterm and long-term assessment scope and timeline. Afterwards, Aditya Jayam Prabhakar will discuss next steps before we adjourn for the day. So with that, I'll turn it over to Ansel Lundberg to discuss Working Group Policy Initiative context. Next slide, please.
Thank you, Christina, for kicking us off here. So I'm Ansel Lundberg in the Market Policy Development Group, and this is an exciting day. We get to look at initial results from the RA modeling efforts that the ISO has been working on for the last nearly year now, since we first met with this group to discuss early model design, key inputs and assumptions, and I think we've come a long way since then. And so excited to dive in and take a look in depth at some of the initial results and review inputs and assumptions with you all, talk about iterations, and just get to know the model and the results. So we can go to the next slide. So just a reminder, on this slide, the "We Are Here" box has moved a little bit to the right. I think the last time we checked in, we released the final discussion paper and recommendations for the Resource Adequacy Modeling and Program Design Working Group series, and that was back in July. And that had key information about the 3 different policy initiative tracks that will be coming out of the working group that we all worked on for the past year or so. And you can look forward to seeing the issue paper come out soon for those 3 tracks. But today is really a modeling focused, more technically oriented workshop. Like I said, to review the modeling initial results. But there is a policy context here that I just want to make sure folks are aware of. So I think the focus of today's meeting is, again, hearing feedback from you all. I also want to say thank you again to each of you for whether LSEs providing survey results for inputs for some of the scenarios in this modeling that we've ran so far, but also the rest of this group for feedback on the modeling assumptions that we talked about for the last several meetings. So kind of understanding what's on the table today, nothing that you're going to see is fully baked. I think modeling is always kind of in this state of evolution, but looking to improve and looking for this to be a useful tool for all of us to understand kind of what reliability means in the ISO, and how we can plan for reliability moving forward. So we have kind of a roadmap that you'll hear today, but we are willing to iterate, like I said, and to refine. But of course, we're always willing to kind of move forward more quickly when there are urgent issues. I know slice of day implementation has been top of mind for many in this group, as far as folks who are CPUC jurisdictional, but we're willing to kind of assess priorities and urgency of issues as they come up. So let's go to the next slide, please. So this slide, just a reminder, if it's been a while since you've looked at the final discussion paper that we issued in summer, this is just a review of the problem statement that we arrived on that is relevant to this modeling work. It talks about visibility into the ISO BAA and into the fleet that we have, and understanding kind of the dynamics of resource adequacy through model-based tools. And let's go to the next slide, please. So this workshop, again, is to review our continuing efforts to address the problem statements that you see here. The sub-issue on the first bullet is kind of a specific bullet that covers this modeling effort, but all of this works together to address the problem statement that we worked on in the working groups, based on what we heard from stakeholders. I also wanted to quickly announce a few things about, or a few updates about the policy track. Let's go to the next slide. So these are a list of the objectives in what we're calling track 1 in the discussion paper, also known as modeling, defaults, and accreditation. And that is where we're going to cover these 3 key issues and objectives that you see here. The first one that's bolded talks about the probabilistic assessment to provide comprehensive reliability evaluation. That will be served by the modeling efforts you hear about today. But there are other policy elements in this track 1. And as you can see there, the bottom graphic represents kind of the parallel tracks of the modeling efforts. And we do want stakeholder involvement throughout, as we discussed, but as well as the related policies that are informed by the modeling or inform the modeling. So that will be the other objectives on this list related to updating the ISO's tariff default counting rules and planning reserve margin to reflect reliability contribution of different resource types, and to tailor those default rules to a 0.1 loss of load expectation. And then there will also be more information in the issue paper about addressing ambient D rates and considering the development of a UCAP mechanism for accreditation. So what do those policy parallel tracks mean? Again, there will be sort of technical modeling focused workshops like today, accompanied by more policy discussions. And this is, if we zoom out a little bit, there are other tracks that are mentioned in the discussion paper to touch on outage rules, substitution, the RAIN mechanism, and the ISO's backstop procurement program. So I think the last thing I want to hit on is in the discussion paper, we mentioned September for releasing those issue papers. It is October. We're finalizing the issue papers. We're just kind of finishing refinements, and we want to get those in a really good place to provide a solid foundation for discussion of potential proposals from stakeholders. There are obviously also simultaneous changes happening with the CPUC slice of day adoption and other moving parts. So that's caused a little bit of reprioritization of our efforts, as well as understanding what you all are working on and dealing with those moving parts. So, and finally, the ISO, you may recall, as part of our working group effort, we issued a white paper in January and had a few accompanying workshops to talk about slice of day implementation. The title of that was CAISO RA processes and CPUC slice of day. So that will be, we've revised that based on a few policy changes that have occurred since we issued that in January. as well as based on a few things that we've heard from stakeholders as the implementation process has gone underway. So that will be posted. There's nothing too different, I would say, but it'll be just the most up-to-date information for stakeholders that will come out within the next few weeks. So please look out for that. And then we will meet again to discuss modeling later in the year. You'll hear more about that from the modeling team. So I think finally, I just want to kind of touch on indicators of success to what success looks like in a conversation for today and the ongoing modeling discussion and policy conversations. I think we're looking for, again, developing modeling that is useful and informative for stakeholders and for the ISO as far as reliability planning, understanding that we want to continue to iterate with this group and be in a state of evolution. Obviously, with reliability planning, there's somewhat of a moving target. So we want to learn from the process and learn from stakeholders so that modeling is a tool to help our decision making. That is what I have to share with you today. We can go to the next slide, please. Yes, Steve, question in the room.
It's a quick question. I think at one of the previous meetings you said that instead of 3 issue papers, you were leaning towards 1. Is it going to be 1, or I just heard you say issue papers, so I'm trying to understand.
Good question. So as a result of the working group process, we're developing the issue papers for each of the 3 tracks that are mentioned in the discussion paper at the same time. And so they're going to be issued at the same time as one document, but you can think of them as 3 separate issue papers, and then the tracks will proceed accordingly based on priorities and the stakeholder process. So does that make sense, Steve? Okay. Go ahead, Partha.
Yeah, this is Partha Malbakar from the KAI. So just to follow up on that, like part of our goal of doing that was just sort of ease of stakeholder participation. So we're, instead of having 3 different sets of comments and 3 different review processes on stakeholders' end, it could be sort of 1. There's also to acknowledge, I think there's a whole lot of feedback on people really wanting to understand the connective tissue between different tracks, and that kind of an uncomfort of having sort of separate comments on separate tracks, and that, what you'll see in the paper when it comes out, I believe, is a whole lot of that. We recognize that each of these tracks really are sort of interdependent between each other. So that was sort of the other basis. But yeah, thanks, Steve, for the question. Thanks, Ansel. Appreciate it.
Yeah, good context there, Partha. Yeah, I'm willing to answer questions as much as I can about process and about timelines. So are there any other questions on what I shared? All right. Seeing none, I think I can hand it over to my colleague Aditya.
Thank you, Ansel. All right. Hiding behind the slides there. All right. Good morning, everyone. Welcome to this meeting again. Like Ansel mentioned, we'll dive deep into the different modeling assumptions, results, take your feedback. Everything that's shown here is draft today. Some of this is useful for our policy direction and how we think about the next steps in this RAMPD process going forward. Next slide, please. Yeah, I feel that this is the most important slide in the deck today. It's important to recognize what this is and what this is not. The assessment or the initiative aims to assess the impact of changes in supply mix. With changes in supply mix comes different system attributes. So as these things change in the future from an ISO standpoint, what is the reliability going to look like? And it also informs future policy direction. It also aims to build a comprehensive assessment of the entire fleet. Similar to what we do in summer assessment, we are looking at the entire fleet of resources in the CAISO BA and assessing reliability from that full pool. Evaluate the BAA reliability in the 1 to 10 year horizon. So not only looking at the near term, but also focusing for every year going into the future, 10 years out every year. This initiative is not designed to expand CAISO jurisdiction over resource adequacy. It is not aimed at setting a minimum PRM. It is not an assessment of individual LRA, RA programs. In California, resource adequacy is a shared responsibility with local regulatory authorities. So that is going to stay. What we are trying to do here is look at reliability from the BA lens. Your question, Steve? No, you're good. Okay. All right, next slide, please. And the other important thing to note is this initiative aims to expand the current coordination that happens between this CAISO, CPUC, and CEC in terms of various planning processes. There is current coordination and roles for long-term planning that's outlined in the MOU will continue. The CPUC will still be responsible for developing forward-looking resource portfolios in their IRP proceeding that is going to be used in our transmission planning process. Reliability assessments are conducted by CPUC as part of its IRP and RA process. CEC also conducts some reliability assessments. We will work closely with both of them to align inputs and assumptions in respective assessments to the extent possible. So, next slide, please. Yep. What are we going to show you today? We are going to show you a comprehensive assessment of the entire BAA RA fleet. And there is also a draft CAISO year ahead assessment result in 3 different looks. We are looking for your feedback and input on how to help improve our modeling assumptions, modeling methodology. So everything is on the table. We will bring you updated results in the coming months after incorporating all of your stakeholder feedback. It aims to do 2 things. One is we are going to update the default planning reserve margin and default counting rules that we have in our tariff, as we've mentioned. So this initiative will directly update those numbers. And the analysis can also help inform the working group's policy development direction. We'll also talk briefly about the scope of midterm and long-term assessment. Next slide, please. So from an ISO standpoint, the CAISO system operations must ensure reliability in a changing system, right? On the left-hand side, the LSC showings process gives ISO some RA capacity that is shown, right? There are 28 different local regulatory authorities, each with their own specific counting rules and planning reserve margins. There are a ton of LSCs that all are part of the LRAs, and then that gets shown to the ISO, right? That's one aspect of what is available to the resources. But then the control room floor, the ISO has to manage load uncertainty, the system conditions, like the BTM, PV, and storage electrification changes that you see in the near term. You see load changes, extreme weather events, gen and transmission outages, imports availability, hydro availability, and demand response, flexibility of resources. So there's a lot of moving parts that the ISO sees in trying to, as we ensure reliability on a 24/7, 365 basis. There's also strategic reliability reserves that are available for use in emergency operations. When to trigger that, what are the criteria and all of that. There's a lot of thought process that goes into all of these things. Next slide, please. I'm assuming I don't see any hands raised, right? I'm keep going. Okay. This is a slide that shows the NQC megawatts of future resources from all the LSE plans. As you see, there is a significant increase in battery, solar, and wind resources. Those are both energy and availability limited resources. They come with their own set of attributes. So it kind of sets the stage for us to really think through the reliability of the fleet into the future. Next slide, please. So a rapidly transitioning fleet requires us to do a forward-looking assessment. The bottom arrow is indicative of how uncertainty increases as you move from near-term assessment to a longer-term assessment. So we've broken it down into 3 different blocks, which we've communicated in previous workshop material, where we said you want to break up the short-term year ahead assessment in 2025. Midterm is looking at years 2, 3, and 4. The focus there is to see with authorized procurement of resources. So you have a certain level of resources that you expect to see in 2, 3, and 4. With those resources and known changing conditions, you assess reliability there. And in the longer term time frame, years 5 to 10, you take all the LSE plans and then you assess based on are the plans sufficient to meet a reliability standard of 0.1 LOLE in the future. Next slide, please. I'm going through these slides fast because there is going to be a lot of discussion as we get into the models and data. So the metric we propose to use is loss of load expectation. It's 0.1, 1 in 10 LOLE metric to assess if the ISO BA has sufficient resources to ensure reliability. What is on a high level LOLE modeling? It's a method to probabilistically determine the likelihood of loss of load under different grid conditions given a certain level of capacity on the system. So you take capacity and their fleet characteristics, you throw a range of possibilities in terms of your known weather load, wind, solar, forced outages conditions as probabilities. Then you run a multitude of scenarios to probabilistically determine what's your likelihood of loss of load. It'll ensure, it will measure whether the capacity that is assumed in that model meets a reliability standard of 1 in 10 loss of load expectation. It's a repeat for all of you. 1 in 10 is 1 event in 10 years, kind of a measure. The probabilistic assessment in the CAISO's way of looking at it is measures the potential for calling on additional measures. So all of your emergency resources, for example, are not part of the assessment. Those resources are not modeled here, which basically means when you see a loss of load here or unserved energy and shown here, it doesn't basically mean it's go out. It basically says you call on emergency operations. Depending on what the magnitude is. So that's why we started looking at the magnitude, the frequency, and duration of events, as will be presented in the slides today. Next slide. All right, so the first step is to determine a portfolio that meets a 0.1 loss of load expectation. If it doesn't meet, you add resources to get it to meet. If it meets, and has a surplus, you take out resources to get it to a 0.1. Once you get that 0.1 portfolio, you establish counting rules for all resource types, apply those counting rules, and then you determine a planning reserve margin that. And then the updated planning reserve margin and the counting rules that we all discuss and agree on would then become the ISO tariffs default counting and default PRM that will be used. That's the next steps. We are here today, and our plan is to get those things in the tariff by Q2 of 2025. At least work in that direction. Next slide, please. Our modeling effort is progressing and improved, all thanks to extensive stakeholder engagement. If you remember, early in the year, we conducted an LSE survey. We got good amount of data that informed our modeling process. That we'll talk more about that survey later, but we got a lot of data, really good data from survey respondents. We've applied that data that we've got from the survey. We had to make some assumptions. We did that, and now we have models that we have. A draft input and assumptions document is also posted on this webpage, where you can see all the different assumptions that went into this Plexus model. Those also are on the table for us to revise and refine. Today you'll see some draft results, and we'll seek stakeholder feedback on certain specific questions that will improve all of this data here. In November 19th, I think we are planning for, we have another follow-up discussion that has some preliminary midterm and long-term results. That will be available, and then we will in Q1, Q2, or we will bring you back the models that meet a 0.1 LOLE and all the other results. Next slide. Yeah, this is wrapping up my section. I'd like to repeat and reiterate, reliability is a shared responsibility. And we all know California's electricity system is undergoing several changes. Your resource mix is changing, load growth, load centers, electrification, your demand shapes are changing. Climate change, extreme weather events have increased in frequency and unpredictability of demand and generation outages. So there's a lot that is already happening and projected to happen in the future. So and really understanding the reliability of the fleet into the future and longer study horizons can help enhance CAISO's and LRA's awareness of future vulnerabilities, and we can take appropriate steps to ensure reliability now into the future. It's also important to emphasize that this CAISO study is not intended to replace CPUC's IRP process. As I mentioned earlier, the CPUC will continue to be responsible for developing long-term resource portfolios that CAISO uses in its transmission planning process. And same applies to non-CPUC LRAs. This study work is not intended to replace any existing LRA RA processes. And what can the CAISO study work can provide a transparent source of information and for the CAISO as the grid operator to best understand future vulnerabilities and risks and prepare for them. So that's a high-level overview of what we're going to do today, what our plan is. I see a question in the room.
Yeah, you're probably going to get to this later, but just when you're doing this analysis and you're looking for a PRM, how do you deal with the fact that the CPUC is using slice a day, so the PRM is really different than what would be for the other entities who are still using the point? Is your estimate just coming out with like the peak hour PRM And is
Oh,
that,
in the default rules, you mean?
yeah,
Yeah, I have a question for that in the end to see
Okay.
how we want to define that. Right now, the idea is to have a peak hour PRM and counting rules associated with that.
okay.
But then there is an other question I have for stakeholder feedback is, should we also add an energy sufficiency kind of a default check for anybody that wants to use our default rules into the future? So depends on stakeholder feedback of where we go there.
Okay.
Thanks. Yes, sir.
Yeah. Hi, Aditya. Brian Thaker with Middle River. I want to just on slide 17, I think you said it, but I want to confirm. You said, for example, the resources in the strategic reliability program, reserve program won't be factored into the ISO's analysis. So the ISO is really going to, its fleet that it's going to analyze is shown RA, nothing else.
We have three different scenarios that look at different range there. So yeah, but basically in any model, we assume whatever the resources are there, but anytime you see an unexpected unserved energy event happening, it basically means that's the time we trigger emergency operations and tap into additional resources.
Okay, so so you're going to, the resources will be modeled,
Yep.
but only triggered under emergency conditions. But beyond it, what you're trying to do is assess the adequacy of the RA fleet, correct? So, for example, if we get 10 years down the road and there's a surplus of generation, are you going to only model shown RA and assume that that's available for the ISO's use? Or are you going to model resources that are existing but are not under contract as RA?
I'll not answer your second question right now because it depends on the scenario that we are studying. But conceptually, you take a set of resources, whatever they could be, shown RA, all RA eligible, or shown RA plus energy only resources, depending on what we are trying to study in that scenario. Only those are available to meet the load and changing load conditions, right? Anytime you see an unserved energy event pop up in that simulation, it basically means you're triggering emergency operations where you tap into these other resources of RDRR and ELRP and strategic reserves that you turn on the OTCs and things like that. That's what this model is implying, because loss of load basically means you're not planning for a loss of load. That's what this is kind of clarifying, caveating, if you will. Thanks. Lauren, and then I'll come back to you.
Okay. Yes.
Hi, this is Lauren Carr from CalCCA. I think you mentioned that when you calibrate the portfolio to meet 0.1 LOLE, you add or remove resources to do that. How do you determine which resources you're adding or taking away?
Can we wait for that also, because it's
Yes.
a long answer? Thanks. Short answer is we take out imports. Yes, sir.
Don't worry about it.
Okay, thanks. All right, any questions on?
We got a question in the chat from David Francis asking, in the context of page 16, I thought I heard the speaker use the phrase authorized procurement in context of new or additional resources. Is CAISO expecting market-based supply additions beyond those mandated to LSEs?
In this study, what we did is we conducted a LSE survey. So anytime a survey respondent gave new resources, we've incorporated those into the model. But if in absence of future year information, we just stuck with the authorized procurement level.
No further questions in the chat.
All right, thank you. I think we are doing really good with time so far. So instead of taking a break, is it okay if I pass it to Mark to go to the next section and talk about a really high level overview of resource adequacy refresher? Thank you.
Thank you, Aditya. I'm Mark Kuchter with the California Independent System Operator. I'm going to be talking about resource adequacy at a high level. And really what that comes down to is what we're looking at it is the ability for supply to meet demand under reasonably expected situations. Next slide, please. So the California ISO oversees about 80% of California's electricity load. This includes about 28 LRAs that set their own planning reserve margins. They and set their own resource accounting rules. The California ISO has a 15% planning reserve margin that's set by peak load for each month, which is the default. But most LRAs are setting their own, even though many of them are aligning with that 15% default PRM. The default rules only apply when LRAs don't set their own rules and establish them. But those default rules are there. They're part of the tariff, and they're an important thing for us to be aware of and see. Next slide, please. As Aditya said, the RA program is collaborative between many different groups within California and the system operator. We have the CEC, which provides a lot of the IPR forecasts, or the California Energy Commission. The LRAs set their own RA methodology. They set their credits. The ISO does the flex requirements and local requirements. There's lots of analysis that gets done, both the CAISO for the LRAs and other entities to make sure we know what's going on and have that understanding, continue conversations about reliability. And then there's the demonstrations that happen on a monthly and annual basis, mechanisms to ensure that resources are showing up the way they're supposed to, and there are there, as well as backstop options in case we are concerned about reliability situations or resources aren't showing up the way they need to. Next slide. Most LRAs have a PRM that is equal to or greater than the CAISO's default of 15%. Notably, the CPUC has a 17% PRM, and they serve over 90% of California's peak load. So on average, though, we are seeing about a 16.7% PRM requirement from LRAs. So that's a load weighted average. This is in addition to, even with this PRM, we are seeing that LSCs do tend to typically provide additional RA capacity over that amount. It varies by month, but they do tend to be over that in aggregate. And again, I want to iterate the PRM, and we've discussed this already, that the CAISO sets the default tariff is based off of the peak month. And there are some differences with how different LRAs are handling that, which is important to be aware of. Next slide, please. The CAISO does have default qualifying capacity criteria or counting rules. This represents what capacity a generator is able to or eligible to count towards meeting its RA requirements. This capacity can be further reduced to a net qualifying capacity based off deliverability restrictions on a plant-by-plant or specific resource basis. These default rules vary depending on the type of resource. For wind and solar, it's historic performance in hours 13 through 19. Energy storage is based off of sustained 4-hour dispatch capability. Thermal is tied to the net dependable capacity. Dispatchable hydro is also tied to the net dependable capacity with some consideration for average dry year reservoir levels. And demand response looks at past performance during availability assessment hours. These criteria are focused on the type of resource being assessed and doesn't really take into account interactive effects between those resources and changing load shapes and patterns that we're seeing. Next slide. These changes in the resource mix, the load profiles, reliability risk means that the default counting rules are outdated at this point. LRAs have provided criteria to the CAISO for their own rules about what type of resources may be eligible to provide qualifying capacity. And we have not needed to use with the CAISO those default accounting rules to set those qualifying capacity amounts. While the default rules at the CAISO have not been used, they are used explicitly. They are used as a starting point for a number of LRAs to set their own qualifying capacity amounts. Next slide, please. With all the changes that the CAISO system has undergone and continues to undergo, that's a big change since we developed these PRMs and counting rules. The LRAs, as we've said repeatedly, they're maintaining their own programs. They have those there. They have their own resource counting rules. Even though the CAISO default rules are the starting point for some, those LRAs still see a need for an adjustment from those counting rules. Most LRAs are setting their PRM at or above our default PRM with a load weighted average of 16.7%. And though we have the adoption of slice a day coming, there's a large portion of the CAISO load that doesn't align with the typical peak hour PRM setup. So we need to be aware of how that interacts and what that's going to look like on our system and how we assume things. And then the default counting rules, they are out of date at this point and reflect and do not reflect current or expected future conditions and changing resource requirements. Next slide, please. And with that, I am wrapped up, and I don't know, do we want to continue going, Aditya? And I can
We
pass
do
them.
have one question in the chat from Leah Caffin asking, for out-of-state wind resources, are you using their wind profiles?
We do have wind profiles in the model. I'm going to let Sai address that as part of the inputs and assumptions. Yes.
Do you have any idea how many of the other LRAs are using the default counting rules and how many of them just use essentially what's in the NQC list, which is pretty much determined by the CPUC stuff?
I don't know how many are using explicitly the NQC list versus their own accounting rules, but at this point, we have not had to use the CAISO default accounting rules as the CAISO.
Just to add to that, this is Abdul. I mean, I don't have a number, but everyone, everyone who is submitting showings to the CAISO is using the CAISO's NQC list. I think maybe you're asking, Steve, how many LRAs have their own Q technology?
Well, actually, what I'm getting to is for 2025, there's a big change in that NQC list for solar and wind for that matter. And I'm just wondering, it's a question of what are you expecting to see and maybe how are you going to deal with it? Because if they just use what's in that list, but they're not adopting a slice a day, it's going to really skew the results.
That's a very good point. I think we're in discussions with some of the LRAs about that, but from our perspective, our rules, there's nothing stopping them from using the NQC list as is. But we're in discussions about the potential impact without them making changes to their own requirements.
Okay.
Partha?
Yeah, what Abdul says is absolutely right. Just to add to it, I do think that's sort of an important portion of this discussion going forward. And I think we're going to get feedback on that is sort of, part of like that's sort of come up in multiple venues, the idea that like, given these changing QC values, what is the, appropriate, PRM that would meet, like, for example, a 0.1 LOLE. And so I think that's sort of one of the questions that's sort of being teed up in the paper, at least, is sort of what should the ISO's role be in that, given sort of these changing program designs? How can we provide transparency and information such that everybody knows what the PRMs that are required in order to meet that, beyond the PUC, if they're actually applying those same QC values in the other LRA programs? So yeah, it's a good question, Steve. And so, yeah, thanks for raising that.
Brian?
Yeah, thanks, Mark. Brian Thaker with Middle River Power. Could we go to slide 24? I greatly appreciate that the ISO is, committing to update its default PRM. I'm sorry, I got a different 24. I think it's maybe the next slide. Yes, thank you, that one. So again, I appreciate the ISO committing to update the default PRM, but I think there's even more daylight than what this table would show, because currently we're under a regime where there's an effective 22.5% PRM in the summer. And we've seen the slice a day results that, indicate that it was 26.5% for 2026, January to May, and 23.5% June to December. So just a nit, I think that it would lead you to conclude that there's even more daylight between where the PRM is headed and where, the 15% PRM that 24 of the ISO LSEs are complying with right now.
Thank you. All right. Are there any other questions? No. Okay. All right. Thank you very much. We are still doing well on time. So I think we'll pass it off to Sai to start talking about the inputs, assumptions, and study design. Thank you.
Thanks, Mark. Can you guys hear me okay? And see me okay as well?
Yes.
All right, perfect. Good morning, everyone. This is Sai Kopulu with the modeling team. So let's see. Okay, so like Aditya mentioned, these are draft results and draft input and assumptions that we are seeking stakeholder feedback on. We will refine the INAs and publish new results. I think probably later this year. So, and also a detailed INA document is posted on the web page. And some of these input and assumptions were also used in the 2024 summer assessment. And the model for that summer assessment is posted publicly. So if anyone has access to Flexos and would like to look at that model and see and look at a more detailed like input and assumptions, I think that's a good way. So yeah, next slide, please. So this slide shows the high-level representation of the zonal topology that we've implemented in our Plexus friction cost simulation model. So for California, we have 4 zones model: PG&E Bay, PG&E Valley, SCE, and SDG&E. There are no intra-zonal limits enforced, but we do have interzonal limits enforced between these 4 zones. We also have a Path 15 nomogram defined between PG&E Valley and the CE. And with respect to out-of-state imports and exports, we have a zone dedicated for economic imports and exports, and we also model out-of-state pseudo-tie generators and dynamic imports that some California entities have contracts to serving California load. And all of these outside imports and exports are subject to a net import limit, and that varies depending on the scenario we're modeling in the year time frame that I will go over as we move on to those sections. And I've also listed here the path ratings for the lines that we model between the zones, and also with the external zone there, and also the import and export hurdle rates, which are used in determining when the imports and exports are happening with the Kaiser balancing area. Let's see, and yeah, each of these path ratings and the hurdle rates are determined from a deterministic model run. Was I think last run in 2022, and I think that model is also posted onto the website. I think I should have included a link. I think I did include a link in the INA document for that deterministic model, which is used to determine these path ratings and hurdle rates. Right, next slide, please.
Hey, Sai, I have a quick
Yeah.
comment. Yeah, this is Ansel Lundberg with the ISO. I just wanted to share, so as the policy representative up front, I'm not a probabilistic modeler, and I know some of our stakeholders have varying degrees of comfort and familiarity with these modeling efforts. I just would encourage stakeholders to, if you have a question, go ahead and raise it, because there are some complicated assumptions and structures in these slides. Sai does a really good job of explaining them, but please ask questions if you have them. Also, just a preview, we're going to give 4 weeks of time for comment on this material. So please, you'll hear more about how to reach out to us at the end of the presentation, but just wanted to put that forth. So, and Steve?
I noticed on that last slide, you show that the capabilities between PG&E Valley and SCE are minimum 3,000, maximum 4,000, but elsewhere in here, I thought you said that the limit on Path 26 was set at 5,000. I don't understand how they're different.
Yes, yeah, we did see that limit, but the limit that we're actually using, I think there is a priority order in the model that is set up for between the constraints that are enforced and the path rating. So in this case, the path ratings that we're enforcing between the PG&E Valley and SCE is the limiting factor. So the model actually uses 4,000 for the limit between those two zones.
Okay, thanks.
We have a question in the chat from Paul Nelson asking, can Sai please summarize how the import-export hurdle rates impact imports?
Yes, yeah, if you go back to the previous slide. Okay, so the import and export hurdle rates come into factor when the model's CAISO energy price, when it compares the CAISO energy price to the external, to the import and export hurdle rate. So for example, if the CAISO's energy price is, or the market clearing price is higher than the import hurdle rate, that means that the power is cheaper outside, so it economically can import from outside. And the inverse is true for export. So if the export price, which is determined by the hurdle rate, is higher, it means it is economic to export out. We do have some limits or constraints enforced in the model so that we don't excessively, like import or export. So that's how we use the hurdle rates in conjunction with the CAISO market clearing price in the model to determine when to import and export economically. I hope that answers your question. All right. I think if there are any more questions, can answer,
Nope.
but if not, okay, perfect.
Not seeing any more in the
We have one in the room, actually.
Oh, okay.
Hi, Noah Tom from Middleware Power. Can you go to the next slide? Can you talk about the forced outage rates again? It seems to be a decade off, slightly.
Yeah. Yes. Yeah. Okay. So forced outages. Yeah, we are aware that they're off, and that's one of the input that we are looking to update in the next round. We are seeing stakeholder feedback there, also and updating those, and that's why like these are draft inputs and draft results. So yeah, that is definitely one of the inputs, and I think the next couple of slides show the class average outage rates that we are using the model. I mean, some are in line with the current outage rates by technology, but some are a little bit off. Especially I think for the batteries, we have, I think we're using a forced outage rate, which is probably not that old because we didn't have that many batteries then. So I think I'm pretty sure we do have to update the outage rates for the batteries for sure. So yeah.
Okay, so following up then, presentation today, asking for feedback within 4 weeks. So we're into November. When are you expecting to update that for the next set of inputs and assumptions? December?
Yeah, I don't have a definite timeline on that, but yeah, we will take your feedback, do some analysis, consolidate.
Well, maybe a different way of asking is, do you expect to do a go, no go based on new data, or it's a go regardless of new data?
We are planning to do another round of modeling results based on stakeholder feedback. So yeah, we will have another round. So it's a definite go.
Sai, this is Aditya. I'd like to probably chime in here, Noah. We were hoping to see how the UCAP discussion goes, because if we were going to clean the data on outages anyways, we wanted to wait and do all of that coding and stuff at the same time. So that's another reason why we're using historical outage rates, while we know that needs to be cleaned up. And the rates are going to be higher. The surplus that we calculate, for example, is going to be less in using those higher forced outage rates.
Well, I mean, why 2012, maybe?
That was the last it was updated. It was never refreshed, and it is less. It is not easy to process that data.
Yeah, I mean, it seems like this is when Slick changed over to OMS, or or RAIM came in, or something like that.
Yeah. Yeah, this is old data. That's another reason we want to update all of this stuff. And we were trying to do all of this, and it takes much longer to come to this discussion. So we said, you know what, let's use whatever we use in our summer assessment. We agree that all of these have to be updated. And I felt like I was growing Chinese bamboo with no activity shown up for many months. And then,
Sorry, I didn't realize the summer assessment has been using 2006 through 2012 outage data to begin with. That caught me by surprise. But okay, but it sounds like it's a go regardless of when the new data set is ready.
Yeah,
okay.
We will have to update that. Yeah.
Got it.
Great, perfect. Thanks for that question, Noah, and thanks for that added context there, Aditya. And okay, for this slide, so since we are doing a probabilistic assessment in the year ahead time frame, we have 4 stochastic variables. So solar, wind, and load. They are produced using a mean reversion stochastic model. So I've included a link here below, which has a more detailed mathematical formulation of how the profiles are created for load, solar, and wind. So as part of our modeling, we have 500 samples created for each of these. So we have 500 profiles for solar, 500 profiles for wind, and 500 profiles for load. And then each single profile for each of these variables is assigned to like different zones, like I've shared in the previous slide, based on the ratio of the contribution in a base profile that we're using to create these shapes. I think I'll go into a little bit more detail about these base profiles in the next coming slides. But the last stochastic variable is the outages variable. So we use the forced outages, and also in combination with some maintenance rates, depending on the scenario that we are modeling, to create these 500 independent samples for generators that have been individually modeled in the in our Plexos model. So for these outage profiles are independent, and they don't have any correlation with these load shapes, or even they're not like temperature correlated or anything. So they are like independent of these other stochastic variables. So all in all, we have 500 stochastic samples for these, each for these 4 different variables. So I think final point on this is,
Sai, we have some questions from the audience.
Yes, yeah. Let me complete this final point, and then maybe I'll take the questions. All right. Okay, so yeah, the final point that I wanted to make is, we have 500 profiles for each of these variables. So that means that we run the year ahead models like 500 different times, so 500 different iterations, and then use the results from those iterations to determine the LOLE metric that Aditya has just mentioned. All right, so I see think we also have,
We have some in the room
Yeah.
first, and then we can go to
perfect,
the
yes, yeah.
ones in the chat.
All right, let's take the ones in the room.
Hi, Sai. This is Carrie Bentley with the Western Power Trading Forum. I had two questions. The first one is, can you talk a little bit more about the temperature independent outages and whether that's a kind of a long-term assumption or whether you were thinking about ultimately connecting temperature with outages because we have so many ambient D rates here. It seems odd that we would have that be completely independent.
Yes, yeah, we did think about that, and I think at least for the first pass, we're not correlating the outages with temperatures. I know one of the policy item for track 1 is also addressing this ambient D rates, and I think depending on stakeholder feedback, I think when we are updating or refreshing these outages, we will think about ambient D rates and doing some kind of temperature correlation. I know stakeholders are definitely interested in having outages correlated with temperature. So yeah.
Thanks. And then can you talk a little bit more about how load and solar are linked? Because we have so much behind the meter solar that when we have high, wholesale solar profiles, that means often we have high behind the meter solar profiles, which is often linked to load. So can you talk about that a little bit more?
Yes, yeah. So the load that we use in our Plexos model is gross load. So that means it includes all of the base consumption, other variables, and it also includes behind the meter solar that we've sourced from CPUC. So for load, from CEC. So in our model, we model gross load, and we also model behind the meter PV on the supply side. And the ratios for behind the meter PV are sourced from the I think from the CPUC PSP, if I'm not wrong. So yeah.
Sorry, so just that last part again. You said it's from the CPUC PSP, the preferred system.
Yes, from the preferred system plan. Yes, yeah.
All right, thank you so much.
Yep, thanks, Gary.
I'm going to follow up on that because, so are you adjusting the load and the solar? Are they, I don't know, they move, different parts move differently, but like if it's a really hot day and there's a lot of solar and we're expecting a lot of the load to be high, but then the behind the meter is high, is that all working together? Or, like if we get one of these summer days where it's cloudy and you're not getting solar, are you factoring in the fact that load's probably a lot higher, but the solar output is lower? Or are they just completely independent?
I believe they're independent from each other, but maybe I'll tap into Wenxiang, who's instrumental in creating these profiles in the room. I think he's in the room. So maybe Wenxiang, can you chime in a little bit on that?
Yeah, the inherent relatedness is based on the profile. So if the load, the particular profile is the 2025, the load and solar profile we use, if they're related, then that's built in the sample creation process. So they're not completely independent, but dependent to the extent that to the base profile they use, solar, wind, and load.
I'll think about that. Thank you.
I think we have another Wenxiang related question in the chat. So when you say, I think it was asked by Arslan Siddiqui. So when you say mean reversion, which model did you use for SDE or OU model?
We'll get back to you with that answer in a bit.
We have another question in the chat from Leah Caffin asking, will you be working towards temperature dependent outages?
So yes, yeah, I think that's the goal, and it's also part of the policy initiative to work on addressing ambient D rates as well. So I think when we come back for the second round, I think we will have put some thought into how to correlate outages with temperature and maybe account for ambient day rates also in the model. So yeah.
Next, we have another question in the chat from David Francis asking, can you provide an example using the export hurdle rates? Pick your own prices.
Okay, yep, yeah, if you go back to the slide, I think, yeah, this one. So yes, so let's say in the model, the CAISO balancing area's market clearing price is $30. And the export price is, let's say, like, yeah, I think maybe that's a bad example. So maybe let's say the CAISO market clearing price is maybe like $5, and the export hurdle rate is like $10, and then yeah, that's on the hurdle rate is applied on the line connecting to the external zone, and then maybe there is depends on if it's an economic export or if it's an export. I don't think we can export to the pseudo tie zones, but yeah, if it's an economic export, then there is a price curve also on that economic export. I think that's in the INI document. So we have the CAISO market clearing price of $5, and let's say for the purposes of this conversation, the export price is 10.85. So that means the export price is greater than the CAISO market clearing price, meaning it's more economical to export for that generator. So that means that there will be export out. But like I said, there is a constraint enforced in the model to limit the amount of imports and exports to the external zone that's the model. So we don't like too much rely on the imports, and also not like send too many exports out. And we also, I think this becomes really important when we come into a loss of load hour. So we did do a sanity check of, okay, in hours when there is we have observed like loss of load, are there any exports out? And there are none, which reframes that, okay, the model is working as designed, that yeah, it is serving the internal generation, and also the imports are used to serve internal CAISO load, and they're not being exported out during those loss of load hours. I hope that answers your question.
Next, we have a hand raised by Nick Pappas.
There, Nick Pappas, consultant. Hope you can hear me. My question, I think, relates to some of the questions already asked about correlation in the profiles, but I just wanted to ask for a bit of clarification or maybe elaboration on the structure of the renewable profiles and load. I see the 500 samples. I'm assuming that's like 500 days. Are those binned into seasons or months? Or I thought I heard there was some nexus to the underlying load profiles from one of the answers, but I'm just trying to get my head around kind of what we're talking about and kind of how that correlation is or isn't built in.
So when I say, yeah, 500 samples, there are 58760.
Got it. Okay.
Samples. So we have 58760 solar, wind, load, and outage profiles.
Okay, 500 of each of those.
Yes, exactly. And hourly, yes, yeah.
Got it. And so the solar and wind and load profiles within each 8760 kind of track sort of seasonal weather, I'm assuming, but may not have the kind of like day-to-day granularity of correlation, like weather simulated correlation that Carrie and Steve brought up.
Yeah, so as long as like the base profiles that we're using to create those 500 samples for load, solar, and wind have some correlation among them, then yeah, they will be like carried over into these 500 samples. And I can provide a bit more information on where we are sourcing those base profiles from in the next coming slides.
Got it. Thank you. That's helpful. Yeah, I'll be interested to hear more about that. Thank you.
Yep, thanks.
Yeah, Chris Devon, Terragen. So I had a couple questions on the solar piece and how you guys are treating that. So first off, I guess, looking at the three different, scenarios that you guys are using, we keep talking about how much RA has been shown on these resources, but we're also talking about the load and wind and solar profiles, these stochastic profiles. So I just wanted to try to understand, are you limiting those wind and solar profiles to how much has been shown in these RA showings, or are you talking about the entire fleet?
So yeah, we're not using the shown values for solar and wind. We are using the nameplate capacity for those in creating these profiles depending on the scenario. Because yeah, I mean, from market perspective, the much tougher obligation for solar and wind is on the forecast value, and I think shown is probably only used for outage substitution. So yeah, so we are using the full like nameplate capacity for the solar and wind and aggregate them by zone. So yeah.
And do you guys also include the energy only solar and wind in that?
So yeah, in one of the scenarios we did consider including energy only solar, and I think there wasn't any wind, if I'm not wrong. So energy only solar that is used for on-site charging of battery resources and is co-located with that battery resource. Yeah, so we did consider the solar, which is energy only.
So sorry, just to clarify, you said you used it for the charging of the on-site storage, but are you guys including standalone energy only solar in the profiles that you're studying here?
No, yeah. So no standalone energy only solar, but only solar that is co-located with the battery and used for on-site charging.
Okay. And then do we have any assumption of economic imports that are just included here that are not shown for RA at all?
I think I can go over that. I think when we get to those slides, I guess we are. I guess I'm
Sorry, I'm
asking all the
jumping the
questions
gun.
that I might.
Yeah,
I might get.
I appreciate
like in the future slides.
you indulging me here.
Yeah,
I'm just
yeah.
trying to
Yeah, no
draw a
worries, yeah.
connection that basically, points out that if we're assuming there's going to be some energy coming out of the grid from resources that are not shown for RA, then we should be thinking about that across the board here, because these solar resources have RPS and REC designations and contracts that will be producing. So we need to think about that perhaps. And I'm just trying to explore and understand that. So the other point I just wanted to make is, looking at how much curtailment is being done to the solar. And I'm just wondering, is that included in these stochastic assumptions? Do you have some kind of a built-in look at the historical amount of curtailment that's been occurring on the system? And do you limit that to only the RA units, or I guess you're only looking at the RA units essentially. So
Yeah, we don't
how
have
do you guys
any.
treat those curtailments?
Yeah, we don't have any curtailments modeled in the profiles, and I think the end goal here, I think during any like loss of load hours that we see, I think we will use all of the capacity that is modeled. So yeah, we don't see any like curtailment in those hours, and don't think we're modeling any curtailment, historic curtailment in the samples.
Okay, thank you.
And the goal of these models is to look for loss of load events, not the other way. We are also not looking at transmission constraints and other transmission outages. It's basically a ball and stick model as represented here. And I also want to take a few minutes to finish your question.
Yeah, I just wanted to respond to that just quickly. The reason I raised this curtailments issue is because if we're just assuming that we're going to get those profiles that come off the solar, but we actually are having curtailment, then the amount of loss of load expectation that's surfaced in certain hours is not going to be accurate if you're just washing away how much of that energy actually can be used to store into the storage and other things like that. So I think we're oversimplifying it perhaps, and we should think harder about how to address these curtailments in the modeling, perhaps. But I mean, I don't have a necessary solution to that or a suggestion of how we would address it. I'm just saying it should be thought about, considered. Thanks.
Yeah, maybe go from probabilistic to do a deterministic run to check, are we meeting our PS requirements? Are we doing all of that? But the other thing on load profiles, wind profiles, quickly based on the questions I'm getting. When it comes to the way these 500 unique profiles are built, there is a base profile that has its own 8760 variation that is perturbed hourly within a band that is based on historical observed variations of energy load and wind production and solar in that particular hour. That gives you a range. This is oversimplification. There's a lot more that goes into the model, but based on how much that weather variations were observed in that hour, and then a random value is chosen between that values. So when a random profile is created, it's informed by what was observed. There is a method to calibrate for weekday, weekends, so that kind of start of the month and years, those are all calibrated, but actual weather dependent forecast is not done, if that makes sense, right? So that's why in our methodology, when you assess these 500 unique samples, we say that captures a range of possibility. But when you have to derate resources from ambient derates, that probably is more applicable in the counting rules framework, where you can derate the resource X amount every month as it's accounted for on a monthly design, or we just reduce its away. There are methods in which you can do a blanket default reduction for resources, like a CC is 5 megawatts lower available in summer than in winter. It is 2 megawatts more than its nameplate available. If that's a monthly profile, we could add those to thermal resources. So there are ways of addressing, but in the probabilistic modeling, it's kind of hard to incorporate weather induced or weather dependent variable, at least from the methodology that we currently employ. Harry.
Carrie Bentley, WPTF. Aditya, do other ISOs handle that by having seasonal Pmaxes and then using those seasonal Pmaxes in the loss of load models?
I believe that's from my previous experience, yeah. But there is in modeling, in IRP modeling that I used to do, we were having a monthly profile for these. Pmax would change every month as a value, but.
Thanks.
Steve Keen from Edison. Following up on that, are you saying that when you do the draws, you're doing them from the same day for load and solar and wind, so that they are essentially getting at least some of the weather normal, that they are kind of weather connected? Or is it just, are those done completely independent? You have that basic profile, and then you said you perturb it based on, if I heard right, some kind of actual output from a specific day. Are you perturbing all three of those, wind, solar, and load, from that same day, or are you allowing them to be very, very different?
So the wind, solar, and they all have a unique perturb window for each hour based on day type, but because that's the base profile will dictate where it is going. But those three are not connected. Those three are still randomly generated cases. So when a Plexus case is run, you pick a wind profile, you pick a solar profile, you pick a load profile.
Okay.
While in reality, there is a possibility of all of those three being connected and within a, like you may mention, on a hot summer day, solar is high. So that variation can be looked at, but yeah, the current methodology doesn't look at it that way.
Okay. And then here's another question. I want to go back to this because there's something I didn't understand, and maybe I'm just being stupid. I want to go back to the hurdle rates. What's the rationale for putting the hurdle rates in? And then how are you also, for that fifth bubble, the economic imports, how are you determining what the costs are for that? Is that done, is it just I don't know, do you have a set of resources that are in there that you're using and dispatching in that economic import and export bubble, or is there some other methodology on how that's done?
So for the economic imports and exports, we have a price curve defined. I think it's a I think at least for the imports, we have a four band price curve defined, and the specifics of that are in the INA document. And the way we determine those is using the deterministic model in calculating the path ratings and the amount of imports and exports, the quantity in that price quantity pair, and also the prices are determined using that deterministic model run. So yeah, it's just based on a price curve, no individual resources modeled. Yep.
Okay, and then I'm still unclear on what the hurdle rates are doing. So you have a demand curve that says they'll supply 2,000 megawatts at $30, but it can't export to the CAISO unless the CAISO price gets above, what, like 40 some dollars? Is that?
Yes, yeah, that's the point of the hurdle rate. So yeah, if the CAISO would only like import or can export from outside if the CAISO price is higher than the external region's price. Yes, so the hurdle rates are used in conjunction with the price quantity pairs that I just mentioned in determining when to import and when to export into the CAISO area.
In the context of the studies here, reliability study, the hurdle rate really doesn't matter. Right? When ISO is short in its capacity, it doesn't matter how much. It doesn't matter how much. What's hurdle rate. In the end, if ISO is short, you always import whatever is necessary, subject to the ISO limit. So the hurdle rate, especially export hurdle rate, only matters in terms of curtailment studies. But in terms of study here, it really doesn't matter.
Okay.
There's no impact.
All right.
All right. Thanks for that added context, Wenxiang. And I know we're getting close to the 10:30 mark for a break. Do you guys want to take a break, or I could just continue on with the slides?
Can you at least finish up the next 3 slides that are on
Okay.
load and solar?
Yeah, I think that makes sense. All right. Yeah. Okay. Okay. Next slide, please. Okay. So this is the output from the mean reversion model for load. This shows the hourly distribution of the load variable across 12 months. And like Aditya mentioned, we use a base profile in order to determine in conjunction with the historical like load values to create those regression ratios and then apply those ratios onto a base profile. So we are using a base profile from CEC's most recent IPER, which is the 2023 IPER, and the forecast for the base profile is based on the 2025 forecast. So the values that you see here, the distribution that you see here is of the managed load. So that means the load values here, they don't include behind the meter PV, but in the model we use gross load and we model behind the meter separately as a supply resource. And the one other point I want to make was, okay, so the 1 and 2 peak for 2025 occurs in July, which is about 46,284 megawatts, slightly higher than the 2024 peak. So yeah, so the peak load month is in 1 and 2 is in July for 2025. All right, if you move on to the next slide. So this is a different way of showing the distribution of load values in the model. So what this shows is, if you look at the zoomed in image there, we have some extreme like load values in the model towards the right end of the histogram that are even higher than the 1 and 2 load forecast, 1 and 2 peak from the CEC's load forecast. So it means our model does take into account some extreme values for load, although with low probabilities. So when we are running the model for loss of load studies and tuning the model to like 0.1, we are taking into account some of these extreme loads can be tied to some extreme events. So yeah. Okay, and then moving on to next slide, please. And this is the same representation that I showed for load, but this is the output of the model, mean reversion model for solar variable. And this is again managed, I wouldn't say managed, but this is a solar distribution without any behind the meter PV values. So the solar variable here are used to create these profiles is an aggregation of in-state solar, any solar components from hybrid resources, collocator resources, and also out-of-state solar. So we use all of that solar to create these 58760 samples, and then we assign a ratio to each of these different types of solar categories for their contribution in their brace profile to be able to like draw generation from them in the model. All right, so I see a question in the chat from Kyle Nevis. Just to confirm, is the behind the meter supply modeled as a separate resource, part of the same draw as the solar supply, or are those uncorrelated? They are modeled as a separate resource, part of the same draw. So we have a ratio defined on those behind the meter solar resources. So they draw from the same 560 samples. Okay, so moving on. Sure.
Sai, we have a question in the room.
Yeah, go ahead.
Carrie Bentley, Western Power Trading Forum. I just wanted to make sure I understood your response to that. So the behind the meter and what I would call, I guess, wholesale solar are correlated because you're using a ratio to create the draw. And so it's basically each solar profile is an aggregation of the same, I guess, I don't know how to say that, perturbed profile. I don't know the right word to use.
Yep. Yeah. So yes, yeah. When you sum up, the ratios for the like the in-state solar, behind the meter solar, out-of-state solar, and all of these, they will sum to one because they are like part of the same stochastic profile for solar. So yes. And
Okay,
yeah.
and then one more question. So then the solar we're seeing here is just the wholesale solar, not the behind the meter. And then the load is just the managed load, so not the total load. But in the model, so basically we're seeing data that's a portion of what's in the model. I'm wondering if we could see the same data. Is that in the, I'm sorry, I didn't have time to go through your paper last night. Is that material in the paper itself?
No, yeah, I think the profiles or the figures that you put in the presentation and the paper, they're all like excluding behind the meter, but the model includes them. But I think we could, I think, provide those profiles. It shouldn't be that difficult to create those.
I would ask maybe if you could do that before comments are due. One of the key things we've learned from the CEC IPER process is the importance of behind the meter solar and its impact on the load forecast. And so I think that's a key input that would be helpful to review before your next turn. Thanks.
Thanks, Gary. And one thing I did forget to mention the previous slide was the base profile that we're using for solar comes from the CPUC's preferred system portfolio. It was most recently adopted in 2024. So yeah.
Sai, we have one more question in the room.
Yeah, when you take when you do these solar profiles, you're getting one for all of California and then just divvying it up, or are you assuming it can be different in north and south?
So when we're creating these profiles, it's an aggregation of all of the solar inside of California, outside of California, and also behind the meter. And then we have these different ratios for each of these different solar categories. For example, for solar that is defined inside of California, it's an aggregated solar, but then we have that defined across 4 different zones. So we have an aggregated solar for PG&E Bay, PG&E Valley, SE, and SDG&E. So we have 4 different aggregations of solar for 4 zones. Yeah,
Okay,
go ahead.
but are those aggregations constant, or do they vary as well?
The ratio is the same, and it's applied to the 8760 500 samples of the solar variable. Yeah.
All right, thanks.
Mm-hmm. Okay, so finally,
Not
the
seeing any
wind.
further questions.
Okay, perfect. Yeah, thanks, Christina. So finally, yeah, these are the wind profiles. So wind variable is an aggregation of in-state wind and any out-of-state wind, and also if there are any like hybrid or co-located wind resources. So I don't think there are, but we'll include those in the aggregation, creating the wind profiles as well. And so yeah, the wind-based profile that we use here is based on our CAISO EMS data from the past 5 years, which is normalized based on annual installed capacity. Okay, so moving on to the next slide. Okay, I think this should end the topic on stochastic variables for solar, wind, and load and renewable resources. So yeah, like I said, so solar and wind are modeled with nameplate capacity because and then depending on the scenario, the nameplate capacity can vary. And then we also model the hybrid and co-located components of solar and wind, and we make sure that we enforce their respective, like Pmax constraint for hybrid and any aggregate capability constraint for the co-located resource. So we do take into account those constraints in the model, so as not overestimate the capacity in the model. And as for other renewable resources such as geothermal, biofuels, and small hydro, they're also modeled on an aggregate basis, and the capacity for those vary by scenario, depending on what's the source of the portfolio for that scenario is. So yeah, I think if you go to the next slide.
Hey, Sai, this is Ansel. I think this might be a good place to pause for a break.
Great. Yes, sounds good.
Nick's question. Answer Nick's question. And
Oh,
then
yes,
take a
we
break.
have one question there. Thanks, Aditya. Go ahead, Nick.
Hey, thanks, Aditya and Ansel. Nick Pappas, independent consultant. I have a quick question, and I have more of a discussion question, which maybe I'll hold till after the break. But I'm just trying to wrap my head around the perturbations approach. And sorry to bring us back into this territory. Just trying to understand. So perturbations are independent across profiles. So solar, wind, and load are not. They're independently perturbed. Is that accurate? And then kind of as a follow-up, are the perturbations within, let's say, a single load day, if you draw a perturbation up in hour ending 16, is that independent, or is there a dependency for then the subsequent hours to kind of follow the same trajectory? And I ask this in the context, just trying to get my head around kind of how we're representing extremes in this approach.
Yeah, perturbation, again, the stochastic process, it's a mean reversion process, and the detailed documentation is actually, it's very well documented in Dr. Susan Liu's 2014 testimony. So it should be on the ISO website. and it has all the equations and descriptions and how stochastic process work. So using the same process. So it's again it's documented, well documented in ISO website.
Thank you. I would love to take a look at that. Is that linked in the INA document?
Yeah, Nick.
Or if not, is it possible to circulate?
Yep, yeah, it is linked in the INA document, and it's also on the slide. Think. Let's see. It's one of
Slide 30.
Slide 30. Yes. Yeah.
Okay. I'll dig a little deeper there. Thank you.
Perfect. Yeah. Thanks, Nick.
Sai, we have one more question in the room.
Hey, this is Perry Servideo, California Energy Storage Alliance. Just a quick question. I wanted to get to it before you got to this slide, a general question about the outage modeling. Do the scenarios include outages on energy storage resources?
Yes, they do.
That's part of the 58760s.
So for storage, we had to come up with a different way, but yeah, we do have 500 different D-rate profiles for storage resources. Yes.
Okay, and are you going to talk about that more after the break?
Yes, yeah.
All right, thanks.
All right, Christina, should we do
We
5
can.
till
Sure.
10:55?
We will return at 10:55. Hi, everyone. Welcome back. Back over to you, Sai, to conclude your presentation.
Perfect. Thanks, Christina. So I think we've received a question in the chat from Mohan Nirola. I hope everyone can see the chat question, but I'll read it. So as shown, wind and solar is modeled with varying monthly Pmax. However, RA capacity to meet LOLE is based on NQC values of solar and wind. NQC values may be lower than the Pmax. How is this different factored in the modeling and the RA showings? So with respect to this question, so for solar and wind, although our graphs in the presentation, they show the shown values and the NQC values, just so as a comparison, to the obligation line in those graphs. But for our modeling purposes, we model solar and wind based on their Pmax or nameplate capacity. So yeah, and then they are used to create the profile. So yeah, for solar and wind, we're not using the NQC or shown values. We are modeling based on Pmax. And then how is behind the meter solar or BESS or behind the meter BESS netted against load forecast in the modeling? So for behind the meter solar, so in our model, we consider gross load, which includes the behind the meter solar, and then we explicitly model behind the meter solar, and then they are netted like 1-to-1. So yeah, we treat behind the meter solar as a separate supply resource.
And we just got one more question in from the chat from Andrew Mills asking, on slide 30, how are resources with dynamic schedules or pseudo ties treated in the 5500 import limit constraint? Are they treated as inside CAISO, so not modeled as an import, or outside CAISO such that they contribute to the limit? The CPUC uses 4,000 megawatts as their import limit. Perhaps treatment of these dynamic schedules explains a portion of the differences, but it is not clear.
Yep, that's exactly right, Andrew. So the 5500 import limit is, including the pseudo ties and dynamic schedules. So any generation from those resources is counted against the net import limit. So you could say the 4,000 limit that the CPUC uses versus the 5,500 that we use during the summer net load peak hours. The difference being those imports from, the unspecified imports or generation from those unspecified imports, for example, Palo Verde, Hoover, Sutter, Intermountain. So yeah.
Yeah, and both are the same. So 5,500 includes 1,500 known
Yeah.
resources and 4,000 very exactly like the CPUC modeling.
Yep. Yeah. And Ansel says, please go to slide 29. So maybe can we jump to slide 29, or is that for the
That was for the imports question, yeah.
Okay. All right. Yeah. No, thanks, Ansel. Okay. All right. So now I think we were in slide 36. Maybe it's 37 for you. I think we're off by a slide. Yep. Okay, this is the one. Okay, so forced outages and maintenance outages were relevant depending on the scenario that we are modeling. So yeah, I think based on our discussion, yes, the outage rates that are used in the model, they need a refresh, and we are going to refresh those for the second round of modeling. But for now, these are the outage rates that we are using in the model. So some of these have explicit forced outage rate and maintenance rates defined. And so the outage variable is also stochastic. So we have 500 different profiles for individually modeled resources, and the forced outage, like I said, it is independent of the other 3 stochastic variables. Also, there is no correlation with temperature for now, and also I think we consider ambient day rates as well. And with respect to like planned outages, the model ensures that planned outages are concentrated during the shoulder months where there are like high capacity reserves, and yeah, depending on the modeling scenario, where substitution is assumed for planned outages, we are not modeling planned outages in that scenario. So we use Plexos's inbuilt module to create those 500 unique random samples for the resources inside of the CAISO, using these outage rates in the model in combination with other parameters such as the mean time to repair, for example. So yeah, I know Perry had a question here on battery outage rates. For battery, yeah, like I said, probably that needs to refresh. So we are using a 5.2% combined outage rate for battery resources. And the way we model battery resources in the model is on an aggregate basis. So we have an aggregated battery for PG&E, an aggregate battery for SE, and an aggregate battery for SDG&E area. And we model it based on a D rate factor such that each of the 500 profile has this 5.2% like D rate reflected on the battery storage capacity. But for others, generators which are individually modeled, the samples are more like binary. So we have like 1 and 0, 1 and zeros, such that the combined outage rates like equal the rate specified in this table here for that technology class.
Hey, Sai, this is Perry again. I had a question about this, if this is a good time.
Yeah.
And I'll try to keep focused just on the forced outage and maintenance outage topic. I do have lots more questions about the inputs and assumptions for how batteries are modeled generally. But as it relates to this, so I'm first just, I'd like this just in, layman's terms here, as much as we can in this subject. It was kind of confusing in the document to me when it described the energy storage outage rate here. So let's say it is 5.2%. Is it modeled as just a general D rate on each of those? You said there's probably like 4 or so storage resources modeled. Is it just modeled as just a 5.2% D rate on it, or are we actually showing, the full, a full resource being out in one of these, 500 scenarios for a couple days? Or can you just give me a little bit more flavor about that aspect of the modeling?
Yes, yeah, it is only a D rate that is being modeled, which constitutes to that like 5.2%. So we are not modeling battery resources like individually. So that's the reason we couldn't, like have like one unit out or represent it in the form of like a binary, like 1 or 0 in the outage profiles. So that's why we have like a D rate for those aggregated batteries. So for example, we have, if you look at like one sample, it's like 94.8% in one of the random cells. That means there is a 5.2% combined outage rate.
So you have 10
that,
gigawatts of batteries. You're just modeling them as 9.4 gigawatts of batteries.
Exactly.
Okay. And then the other question, just on this table, I'm noticing that, for the first 3 and geothermal, it's this shared rate. And then, when you get to cogen, it's the same rate, but it's in 2 different columns. Is this just how you're not really separate? Is this just because you're not really separating out, say for energy storage, you're not really separating out the individual resources, you're just derating it, so you can't really say, hey, we're going to shove lots of maintenance outages just into the off season or something like that? Am I reading that right?
Yep, yeah. So for these, we're not modeling them individually. So yeah, we have like an availability factor based on these combined outage rates. Yeah.
Okay, and then remind me, what was the period of time that you used to analyze to get to the 5.2%?
I think,
sorry, for the energy storage,
For the energy storage, I believe it was 2020. I think back then, probably we had 500, maybe 1,000 megawatts of storage. So yeah, we definitely need a refresh on that. I think maybe right now.
Okay, so you look, yeah, but for the study we have in front of us, it was just the 2020 data. You came to 5.2%. Okay, and then does it matter in the Plexus model whether you apply that to the discharge side or the discharge side and the charging side? Is there a setting in there where that matters for this D rate, or can you talk to that a little bit?
No, yeah, I think the D rate is like overall applied on the availability of storage. So yeah, we don't explicitly model storage outage rates on the discharge and the start side. It's just like one outage rate.
Okay, but it's on the energy storage resource though, it's treated as just a D rate. So is it just derating the discharge side of the energy storage resource?
So the way we're modeling energy storage is we have like the aggregated like capacity. We are modeling it based on 4-hour, and then we have corresponding like energy. So thinking, if we are derating on the availability, then the corresponding like the charge also will get automatically derated.
And that just has to do with the way that the Plexus model is treating it. Okay, it'd be good to get confirmation or just some language on that into the next iteration, the inputs and assumptions.
Yes, yeah, I will notice that, and yeah, if you could also include it in the comments, I think that would be great as well.
Yeah, for sure. Thanks, that was really helpful.
Yeah, thanks, Barry.
Sai, we have one more question in the room.
Yep, please go ahead.
Hi, this is Noah Tom from Middle River Power. Can you put into the INA doc sort of a definition on how you guys are pulling? Or I know it's from sort of 2006 to 2012 data, but what are the definitions of the forced outage rates that you guys are pulling? Whether, what timing, certainly there's 7 days, but also what type of natures of work?
Yep, yeah, definitely. We'll update the NA doc with that, and believe we are using on the outage level. Not sure if you're looking at from a nature of work detail, but yeah, I will confirm that and update the doc.
I mean, it's trying to get a better understanding on whether or not like transmission related or induced outages are included in the forced outage rate or not, and so on.
Yep, yeah, definitely. And yeah, I think like Aditya mentioned, we will do a more comprehensive update of these outage rates in line with like track one's IMD rate policy, as well as the UCAP policy in track 2. So yeah, we will definitely get to answering all of the outstanding questions there. So yeah, thanks for that, Noah.
And Noah, is it even useful to look at what was that, or just move past and kind of start exploring what we should be looking at?
I mean, I would say it's probably a little bit of both to better understand what you guys are using with regards to an outage rate, whether it be forced or maintenance, and whether or not that should flow into the model, and also to better understand what is already flowing into the model because you guys have already done some draft analysis, right?
Carrie?
Carrie Bentley with the Western Power Trading Forum. So not to disagree too hard with Noah, but I think in my mind, I'm just not going to care about this outage data too much, except for as it pertains to how I'm going to interpret your draft results. And I think my takeaway, and correct me if this is wrong, I think my takeaway here is that these are lower and more conservative compared to reality. So when I view your loss of load expectation results, I should take that as kind of a lower bound. And really, we would expect to have more loss of load under your updated results.
Yep, that is correct. And how much will be dependent on how these things and when these outage rates are applied and stuff. But yeah.
All right, thank you.
Not seeing any further questions in the room. Oh, there's one more question.
Okay.
Sorry, this is Perry from CISA again. Have there been any thoughts internally at CAISO about expanding the energy storage modeling to be individual resources rather than a class per zone? That might unlock some more functionality in this model for you.
Yes, we are looking into that next round. So yeah.
Okay, thanks.
There are many things to do. Like you can do a unit level, you could move it to next version of Plexus Cloud. We are exploring a range of things. And then once the umbrella question is answered, then the corresponding things can be incorporated. Because if you don't do that, then we'd have to stick with this and make certain other improvements in the current version in Plexus we use. So
thanks.
Yep, yeah.
Not seeing any further.
Yeah, it is to add on to what Aditya said. Yeah, I think, yeah, it's like kind of like a balancing act to maintain like a reasonable level of accuracy and also not lose, not lose the computation time, because yeah, running all of these stochastic models is very computationally intensive. So we try to make like reasonable assumptions and approximations where possible without too much loss in the output results. So yeah.
Yeah, thanks for that. I think to Carrie's point, though, looking forward into the future, with now 10 gigawatts of batteries spread all across California going on 20, this is going to be a big part of the modeling, and it might make sense to seriously consider that.
Yep, sure. Thanks, Barry. Thanks for that comment. So moving on.
One more question in the room, Sai.
Yeah, sorry, go ahead.
Sorry, Carrie Bentley with the Western Power Trading Forum. I was just realizing I don't know how to comment on that because I don't know the other side. Like you said, you can move to Plexos Cloud. So if it were free, I'd say yes, model every battery. It's great. But I'm sure it's not free. So I'm wondering if you can give us an indication in terms of, I mean, I don't care too much about CAISO costs. That's all allocated to load. It'll be like, what, 2 cents per person, right? But no, sorry, Noah. But in terms of how long will it take to run a study if you model every battery? Will those results be as consumable? Can you kind of give us a flavor for that? And then I guess if it is $1 billion to go to Plexos Cloud, that would be helpful for the load in the room.
Yeah, those are some of the considerations of cloud and then a cloud strategy, the ISO. So there are a lot of internal questions that we are addressing, and then value for cost, and then can we live with this? That's the reason I want to give you all of these draft inputs and assumptions is we did a reasonable representation of these outages, a reasonable representation of these profiles, and wanted you guys to have a better overview of how these models are running. And when you move to the new version of Plexus, it'll give you a little bit more flexibility in terms of the detail that you can model, but also looking at the cost. So we will see, and how frequently these things need to be done as another consideration. If it is an once in 3 years effort, then
Will the results take longer to run?
in the server
I see some
space,
nods over
yeah.
there. Yeah.
Yeah, in our internal servers, yes, but cloud is a little bit faster, is what we are told. Yeah. All right, back to you, Sai.
Right, thanks for that, Aditya. So yeah, moving on to the next slide. I think the next couple of slides on INAs deal with more like resource-specific modeling considerations. They're more like generally applicable to all of the scenarios that we're modeling. So thermal plants, gas, nuclear, distillate, of these are like modeled individually in the model with their respective operating characteristics and any intertemporal constraints considered. Most of the values are sourced from the CAISO's master file database and used in the model. And yet the plans they provide all of the ancillary services, rig up, down, load following, and also any like spin and non-spin reserves as well. And the fuel prices that we're using in the model for thermal are sourced from the CPUC's IRP process. And with respect to thermal power plants, we are modeling Dablo, like based on the new SB 846 recommendation there. And also, I think we've discussed this earlier. We're not modeling any strategic reserve resources, mainly the OTCs in the model. So yeah, because the model, the main concept of the LLE modeling is when we see loss of load, that is an indication of the balancing area getting into emergency resource, and that's when we have to tap into those emergency resources, and hence we're not including those in our modeling. So moving on to the next slide. Okay, I touched on this a little bit in the previous slides. So battery resources, they are modeled on an aggregated basis by zone, and then all of them have an 85% round trip efficiency. And to the extent the battery resource is part of a hybrid or a co-located pair, we are modeling those constraints separately so that we don't overestimate their contribution in the model. And battery resources, they do provide all of the ancillary services and load following reserves, in addition to required frequency response or headroom reserve as well. And with respect to demand response capacity, it depends on the scenario that we are modeling and the capacity that we're considering for demand response in each of those scenarios, whether we use the shown capacity from the survey or from the NQC list. So that's our source for DR capacity. And the way we are modeling that is with some high triggering prices. So if the energy price in the model reaches that triggering price that we model, then and only then the demand response will be dispatched. And then we do also have some the max runtime and daily start constraints enforced so that they are dispatched at a more realistic frequency. And DR is they're not eligible to provide any of the reserve products in the model. All right, so moving on to next slide. We're coming to hydro and pump storage modeling. So for hydro, we model it based on like hydro, we model it as a non-dispatchable runoff river hydro based on a fixed generation profile. And if it's a dispatchable hydro, we model it by zone, and we consider an average hydro year profile from 2018 to define the daily max and min energy limits. And yeah, the hydro can provide these different ancillary services as well. And with respect to pump storage, we have those units individually modeled and outages defined as well on those units, and all of the relevant like operating characteristics for the pump storage generators are also like defined, as you can see on the slide. Okay, so moving on to the next slide. The next slide just shows the max and min daily energy limits for the NP15 and the SP15 hydro that we are using in the model.
We have a question in the room here.
Okay, yep.
Is it me? Yeah. Oh, okay. Carrie Bentley with the Western Power Trading Forum. Can you go back to your second bullet point there on the prior slide and talk about what you mean by uses that average hydro year to set the daily minimum and maximum limits? Does that mean you've only looked at that 1 year, or are you taking that 1 year and kind of perturbing it up and down to get a range? It's just one fixed profile. Is that right?
Yes, it is just one fixed profile based on like the average hydro year, which we determined to be like 2018. So if we looked at our internal data and then compared it to our 2018 data, actual data, and that's the profile that we are using.
Can you talk about why 2018, whether that's a reasonable assumption, whether it's a low average, or kind of the logic behind that?
So when we do summer assessment, we actually look at snowpack conditions for that relevant year and apply high hydro, low hydro, whatever average hydro, depending on what the snow melt statistics from DWR look like. But when we did this forward-looking RA assessments, we want to assume an average hydro year in our analysis, just to be consistent. So we don't assume high and then we get low and then we assume low. It's average seems like a decent assumption. And 2018 is a representative average snow melt condition. So when you look through that data, that is, I can send you a link to that snow melt data that we use.
Oh, no, that's okay. I don't think I care too much about the specific data. I think I more care about the underlying assumptions. So I think in planning studies, or when you're evaluating something out into the future, the more out into the future you look, probably the more conservative you should be in your assumptions. So I would think that maybe, I mean, average is kind of a very fuzzy, right? When you're talking about a hydro year, average could mean kind of toward the high, kind of toward the low end. So I think maybe if maybe more information about how average 2018 is would be helpful.
Yep.
And then two, considering a philosophy that you would maybe not use the worst hydro year, but use a lower hydro year, because in terms of planning, we really want to make sure we have enough resources for those low hydro years. I mean, I think some people could make the argument you should use the worst hydro year because we need RA capacity to cover that worst hydro year.
Yeah, I will give more information, and then that'll be something that we should talk about, because each level is about 2 to 3,000 megawatts of capacity. A high hydro is 8, 9,000, 7,000 to 6,000 is average hydro, and 2, 3, 4 is the low hydro megawatt. 1,000 megawatts is the range how it gets us more capacity depending on what level you use. So
Oh, that's interesting. That's a huge swing. So, sneaking ahead, right? You had a capacity margin in one of your studies of 1,800 megawatts. So basically your hydro assumption could flip that from having a positive margin to a negative margin.
that's why in summer assessment, it's even more important because then you know actual hydro conditions that get modeled, but in forward-looking RA assessments, yeah, if you all think low hydro, I'm good with low hydro, but
Yeah, no, I think it depends on what the study is for.
Yeah.
Right? Like I agree if you're determining and what you said earlier actually and how often you update the study. So if you're doing it every 3 years to do a PRM and accounting rules, maybe average makes more sense a little bit, or if something more recent, if you have any sort of indication for the following year. But if you're doing a long-term study and you're going to use this to say what resources do we need to keep online, what gas do we need to not let retire, then I think you need to go way down on your hydro assumptions and assume low hydro year because you're talking about long-term fleet sufficiency.
Thanks.
Hey, this is Perry Cisa. I actually had a question on the prior topic, but I was going to wait. But then, this made me think. I have to ask the dumb question on the hydro assumption. Is it possible to make this probabilistic also, where you can do a range of hydro scenarios that are drawn?
And sure, we can do that, right?
Yes, we can do that, just matter of data.
Yeah. We could do low, medium, high. Yeah.
Yeah, then we're all become weathermen and try to figure out whether it's going to be low or high and what the probabilities are. But okay, back to the energy storage. I think the slide would be the right place to sort of just walk through the modeling there. And you correct me if I'm wrong, unless you have a slide somewhere else. But so as I understand so far, there's essentially 4 energy storage resources modeled at 85% round trip efficiency. Are they all 4-hour duration energy storage, or are there multiple?
Yeah, we considered 4-hour duration storage resources. Yes, yeah.
Okay, and then
clarification. It's a 4-hour state of charge.
Yeah.
But it can be dispatched however it wants.
Sure. So what do they call it, like recharge rate or something like that? It models the amount of stored energy and it can use it.
Yeah.
Okay, that's great. How many cycles per day does it allow on these resources?
So I don't think let's see. I think I should have a constraint description in the INA document. I don't think we have an explicit constraint to restrict this number of cycles to, I think, one more reflective of the operating. And even the CPUC models also don't have any constraint on the number of cycles that a storage resource can do.
So I'm hearing no restriction on it currently?
No, we do have some end volume constraints, all of those reflected, but not on the number of cycles. First, yeah.
Gotcha. Okay, and then is there like a minimum capacity threshold parameter in there where you don't let it go below 50% or 20%, and what is that number set at, if there is?
Yeah, we do have, like the end volume constraint in the model, probably like 5%, maybe not go below like 5% or something like that. I can
But it's
confirm.
something low. It's not like 50%.
Yeah, no.
Okay, I think that's all I have for now. Oh, and then, yeah, I guess I should ask. Is there the capability in the modeling to constrain on cycles, et cetera?
Yes.
Yes. Yeah. Yep. Yeah.
I thought that would be the answer, but it's good to clarify. Obviously, good to clarify. Yeah. there's only 4 resources. No. And now can we just talk about dispatch strategy? You know, like, so I've seen models do this a bunch of different ways. I'm just curious how you guys have this set up. And from whatever, and if I'm describing this wrong, just correct me on this. Because it is a production cost model, right? So it matters in what costs you're putting in to use the energy storage. But let's say you get into that situation where where there is not enough energy and there will be unserved energy. Is there a certain strategy in place that basically does either a first come, first serve, or it tries to minimize the depth of the shortage, or if it tries to minimize the duration of the shortage?
Yes.
Which of the 3, is that something it does or differentiates between?
Yeah. So at the end of the day, yeah, it is a production cost model, and the objective is to minimize cost, right? And it depends on what the horizon is over which we are optimizing in the model. So for battery resources, it is especially important to have that additional like look ahead period over the next day. So it is like a daily 24-hour optimization over which we are minimizing production costs subject to all of these constraints. But for battery resources, we have an additional like look ahead period over the next day to be able to like optimize the battery dispatch of the current day that we are optimizing. So yeah, at the end of the day, it's like minimizing costs, and if that means having unserved energy like in 1 hour means that it would on an overall level like reduce the system cost, then I think that's what it would.
Is there enough differentiation in the cost, or is there a way to set up the parameters of the costs to effectuate one of these situations? Because the way I see it is you get into this situation where there will not be enough energy. There will be unexpected energy, and then it becomes, it might just jump to say the penalty of, expected unserved energy. And that looks the same from a cost perspective, whether you minimize duration or depth, or if you do first come, first serve. So but the way that it tackles that problem does have implications in terms of determining PRMs, et cetera. So that's why I'm asking, in that particular situation where there will be unserved energy, what strategy does it currently use? Is that something that you guys can look at or change within the modeling?
Yes, we can definitely. Yeah, Vincent, go ahead.
Yeah, I think that's something that we should explore. As you said, when the capacity is short, unserved energy costs kick in, it doesn't matter which hour. So currently, we didn't enforce to make unserved energy concentrated in 1 hour or spread. The only constraint we enforce is like any given hour. We enforce like cannot be more than either 10,000 or 30,000. So it's like relaxed. So, but I think we should. I think it's a good point. We probably should explore when we have short energy how battery can be operated.
And to figure out like what it's doing right now, it could be as easy as just looking at those hours in which there were unserved energy and see what those 4 batteries are doing. And you might see that they're just trying to use all of it up front, and then boom, they're empty, and that's it.
Yeah, it won't be empty because we do have constraint like look ahead period, and so and
that's fair. Yeah.
So it's basically the way it's modeled. It's very flexible. It's 85% cycle efficiency and 4 hour storage. It's very flexible. We didn't place any constraint, but as we place more constraint in the system, obviously will be operate differently, and we have different consequences in terms of reliability. Yes.
Okay, maybe we can follow up further offline, but I think I got the answer for now. Thanks.
Yeah, the model has that look ahead. The benefit is, and it's a deterministic view for that resource, right? It'll use it where it is most economical to use that resource. Conceptually, it should reduce that. It's optimizing for that net present value costs. So
yeah, and on all of the days on your chart that are colored with green, it does what it's, I'm assuming it does what it's supposed to do. I'm concentrated on there will be unserved energy. So now what does it do? And maybe we can take that.
Yeah. We'll bring in zoomed views of what the unserved energy days dispatch profile is looking at. We were looking at some of those cases, but what it tries to minimize that hour. So an unserved energy.
It does try to minimize hours. It's so that there's like a couple strategies it could use. If it tries to minimize duration, depth, or if it just tries to exhaust the.
It tries all three, but whatever minimizes the total cost.
Okay, and then yeah, I gotcha.
Right.
Okay.
So sometimes it might be just minimizing the duration. So
Are there stepped costs on more and more unserved energy in a particular hour? Or does it all look the same?
It's just one.
That's the issue. If all those hours, if all that unserved energy looks as the same cost, then I'm not sure that it'll just exhaust the battery, and it's not trying to minimize the duration of the outage or the depth, or spread it over the hours or do any of that. I would think it would just try to exhaust the battery, but it'd be helpful to go look into that, get that clarity.
Yeah, we can look into that.
All right, thanks.
Next in the queue, we have a question from Nick Papis asking, does 2018 reflect an average hydro year versus low hydro?
Yes, yeah. So yeah, based on our 2018. Yep, yeah. Yeah. Thanks, Nick. Yep, yeah. Did discuss that. So yeah. Our assumption for the study was an average hydro year, and we picked 2018 profiles for that. So yeah.
Next
So
up,
moving.
we have a hand raised from Kathleen Colbert.
Hi, this is Kathleen Colbert from Vistra. Can you hear me?
Yes. Yeah. Hi, Kathleen.
Hi. Great job so far. Thanks for all of the information. Still going through it, but I wanted to, while you were on the storage assumptions, just flag a couple things that were on my mind to delve into. The first one is, you're mentioning the assumption of the round trip efficiency of 85%. That's going to both over or undervalue depending on the specific resource. It's a little low of a round trip efficiency for kind of newer gen maybe. So I think you may actually be undervaluing across the fleet, but you would need to look at the registered efficiency rates that are in master file. But I would like to ask you just to do that and get a sense of if 85% is way off the mark. Like, I know we're not striving for precision necessarily here, but a gut check in your next update would be very helpful if it's a good representative of the fleet. But if most of the resources round trip efficiencies are higher, then we might want to take a slightly different approach. Does that make sense?
Yep. Yeah. Thanks, Kathleen. Yeah. Because we are doing batteries on an aggregate basis. We thought, okay, 85 is a good assumption, mainly for lithium ion. So yeah, I think maybe we could probably, I think based on our check from Ashton, maybe we could do probably the capacity weighted round trip efficiency value. Or if you do decide to go on, if you do decide to go do battery modeling on a unit by unit basis, then that would be more resource specific anyway. So yeah. Yeah, thanks.
Excellent. Great. Thanks for taking that one. The second one is on the cycling limits. I appreciate Perry raising that. Also think it's worth thinking through. I'll note that that is not a value that is currently registered in master files. So if you are going to consider cycling limitations, we're going to have to get a little creative until you have that kind of value registered. One thought that I had been toying with and we'll put in comments is, even if you don't do it on an individual resource basis, you could create multiple aggregated resources and aggregate them by the flexible category. So flex category 1 storage will have 2 cycles at least, right? Because it's 17 hours versus flex categories 2 and 3 are only being certifying for a single cycle. So while it's a proxy, it's a reasonable proxy and might have, if you're going to limit storage, I'd want to make sure we're not overly limiting because there are quite a few category 1 storage registered, as you can see on the NQC list and EFC list.
Perfect. Yeah, thanks for that comment, Kathleen. We'll take
Thank you,
that in
guys.
consideration. Yeah.
Appreciate it.
Right. Now, Aditya has a comment.
Yeah, I have a clarifying question. Do we refer to cycling as full charge, full discharge? Or if it is partial discharge, that's not considered a cycle, right? Full charge to full discharge. Okay. Ready?
Yeah. Although I would probably just use the amount of energy used, and if that then is equivalent to full discharge, because I know you're not letting it fully discharge, but if the amount of energy that it's using over the day would equal 100% of its energy, even if it's like recharging, then you'd call that the cycle.
All right, perfect. Thanks for that clarification, Paris. I think maybe we could move on to, I think, the last slide on this topic on the AS and load following requirements. Yeah. So our model uses a single set of deterministic regulation and load following requirements based on a methodology that we outlined in the INA doc and also referenced here. So for spinning and non-spinning, we are modeling it at 3% each of load. So because load is a stochastic variable, spinning and non-spinning reserve requirements vary during each iteration. And then we also do model a frequency response or a headroom reserve with 376 megawatt minimum provision, which only the combined cycle units and battery storage units can provide that reserve product. So we have these different type of reserve products modeled. And when we talk about like loss of load, what do we actually mean and how we like categorize those, right? So our model includes a priority order for shortfall. So if there is a shortfall, first the shortfall like occurs in load falling up, and then we define this priority based on penalty prices. And then if the shortfall is still remaining, then it will spill over to non-spinning. And then if it's again, it will spill over to like spinning, and then headroom, and then regulation up. And then finally, if there's still any shortfall remaining, we'll have unserved energy. So that's how we are defining the priority order for capacity shortfalls in the model. And the way we calculate loss of load events is if we observe any of these capacity shortfalls in spinning, regulation, headroom, and or unserved energy categories. So yeah, I think that concludes my presentation on this topic, on the INA discussion. So let's see, do we have any questions in the room, on the phone?
Maybe I will take a minute and kind of wrap up this section before we break for lunch. Now, what did we share? We kind of shared our ball and stick model in Plexus. It is doing 8760 hourly chronological dispatch. It has resources and their corresponding capabilities are modeled. The wind solar load has its own unique set of hourly production capability profiles. We model the gross peak and the net peak, with including the behind the meter solar. We're looking at it from an ISO BA wide standpoint. We're considering imports adhering to the historical import limits or the 5500 limit, and that is adhering to MIC availability in the other hours. So looking at ancillary services, looking at outage profiles, looking at discharge rates and resource characteristics as it pertains. So think of it as each simulation is a year's worth of operating the grid with that set of resources. And then you do it 500 times to represent 500 years. And then when we come to LOLE conversations, we say once every 10 years, which means you can have 50 event days in the 500 simulations that we run. Yes.
Steve Keen, Edison. Follow up on the imports. One of the issues we've seen in the last few years is that when we get into trouble, a lot of times it's when it's not just hot here, but, when was it last summer when we were, when it got hot in the rest of the West, that's when we had problems. I don't recall you saying that there was any, you didn't put any adjustments in for the import and the export to maybe account for that. Is that true? Import and export is just done as this, the curve, and then, does it get perturbed at all to account for the fact that we may be experiencing a West-wide energy shortage or anything like that?
No, we don't do that. That's not the only constraint we apply is the max import limit available in those hours is 5,500, including from those resources. That models RA external commitments is one way to look at it, but then you can have economic imports above and beyond that. But that level of granularity is not modeled. So the only lever we have is to manage how much import we can assume.
Okay, thanks.
Oh, there is a couple of questions we see. Nick?
Silas, if you could please unmute Nick.
Hey, I think I'm unmuted here. Hey, Nick Pappas, independent consultant. Adequacy team, thank you all for bringing this forward. I know this is a huge effort, and we could probably spend days on each of the categories here. I did just want to ask, Aditya, this may be a question for you. Noting as we go through the CPUC's sort of LOLE modeling approach, and that's kind of continued to go through some of its own machinations, there's a very different approach here with regard to like weather simulation, as we've been discussing, relative to the Commission's approach of trying to use the 20 or so years of aligned weather data. I don't want to say that I have a perspective on which is better, but they're clearly very different. And I was wondering if you have any initial takes on kind of benefits or trade-offs between the two, or ways to kind of have one side inform the other, or how we might want to think about using those two approaches to align as we go forward here. I'll just, I guess, note the context for me in this is I think that weather simulation component is increasingly one of the most dominant unpredictables or difficult to predict kind of random factors. So wanted to highlight that and ask if you have any kind of high level thoughts on where to take this.
Yeah, I'd probably add a little more context to that. So when we give the regression ratios that will inform how much this individual values will be perturbed in the 500 profile development, that is informed by 8 years of history. So that gives you a range, right? So there is some form of climate informed data that is modeled there. But in the future, when we get there, we are planning to work with CPUC and get their future year-based profiles that already has a climate-informed forecasting-based approach. So the 10-year out profile, for example, that new base year and new sets of 500 profiles will be created off of that is one approach. So there is some talking happening between the two methods, but it is not one for one because it's also a function of what the models are able to do and how we incorporate that stuff. Is the first part, and then we're also coordinating with CEC because they are on point to produce stochastic profiles for use, and that is coming in the next coming years, as I'm told. So once that happens, then we'll all have a consistent framework of stochastic profiles to use in our modeling.
Thanks, Aditya. That's really helpful. And I'll say as an outside stakeholder, having a kind of a single series of data to review across the agencies, I think would be great. So appreciate all the cross-agency work there and look forward to continuing discussions on that one.
Yep, thank you.
Next, we have a question from Paul Nelson.
Hi, this is Paul Nelson with the CPUC sound check. Can people hear me okay?
Yes.
So I've got some questions on reg up and down and also some load following. I guess for both of these, is the model then sort of as it's doing the simulations constantly changing how much resources it's pulling out of the capacity stack for reg up and load following? Or is this set as sort of a fixed amount?
So yeah, reg up and reg down, and for that matter, yeah, load following requirements, yeah, they are fixed amount like each hour. They are like hourly, and the INA document should have the distribution of these requirements as well.
Okay, so it would sort of might be possible to sort of translate that into a percentage of load values?
Yeah, we have not done that. And yeah, I don't know off the top of my head too, but yeah, we could probably take a look at that as well.
It's not, you know, one way to, and I think you actually have a slide when you're deterministic, is you sort of count up what makes a planning reserve margin, and you've got 3% for span and non-span, so 6% that comes out of the resource stack. And then the question is it another percent for reg up and another percent for load following? And that's just kind of trying to think about quantities. But I also got a question on that's kind of thinking about the load following up. Well, would you ever want to take out some capacity as you first sort of approach the breakpoint for load following up and say, oh no, it can't meet the load? That's where I'm struggling, is why would you all of a sudden exclude some capacity of our load following up to meet the load? I mean, if it...
Yeah, sorry, I think I don't follow the question, maybe.
Well, if I understand this right, is when you're taking out resources for regulation, those are sort of excluded as resources to meet the projected capacity need. And the same thing you're doing for load following, up or down. But if you're going to start to run short of capacity to meet a peak load, why not go ahead and utilize the load following up resources to meet that load? Because at some point as you approach, at some point you will do load curtailment. And at that point, you've exhausted all the load following up. You still have regulation, and then there'll be resources that get to reg down.
Yep, yeah, I think I do see your point. Yeah, we will, yeah, take a look at that. I think what you mean is for capacity shortfalls. I think when I mentioned we only look at shortfalls and spin, frequency of response, regulation, unserved energy, but not like load falling up and non-spin, right? So you're saying, okay, what if the resources are reserved and providing these other two reserves can be used to actually avoid shortfalls in the other? Yes, yeah, we will, yeah, take a look at that and try to, yeah, respond to you. Yep, yeah.
Thank you very much.
Or unless like Wenxiang already has an answer off the top of his head.
In terms of the actual outage event, we don't count on any of those violations. We only count when we have spinning and reg up and errors. So we don't count any violations when they're only load following.
Okay, yep, okay, yeah, that makes sense. So basically what you mean is when there are only load following up and non-spin violations, we don't count that as a shortfall event, but we count a shortfall event if there is load falling up followed by spin or non-spin and then spin and then break and unserved energy. Yep, yeah, that makes sense.
Does it answer your question, Paul?
So the bullet on load falling up or down then is not a restriction for a violation. So maybe take out that bullet in the presentation then? If I understood what the comment said, that's not being considered as a violation. I'm not sure. I guess I didn't quite understand the response, maybe. Did you say it again?
Yeah, so for example, if in any hour we see a load following up violation followed by a non-spin violation, and then all of the shortfall is contained between these two products and it didn't spill over to like spin, rig up, or unserved energy, then we don't count that hour as via loss of load hour.
Okay.
Yeah. But if shortfall is large enough to spill over from load falling up, non-spinning over to spinning, regulation up, headroom, and then unserved energy, then we count that as a loss of load hour.
Okay. All right.
So
Thank
yeah,
you.
yeah.
Not seeing any further questions. Do we have any final thoughts before we break for lunch? All right, so we will break for lunch now and return at approximately 1 o'clock. Thank you.
Perfect. Yeah. Thank you, Christina. And thank you all.
Hi, everyone. Welcome back. We're going to be getting started again here. Next, Sai is going to be discussing the year-ahead resource adequacy assessment modeled scenarios. Silas, if you could go to the next slide, please.
All right. Perfect. Envision will spend a lot of time than the allotted 30 minutes on this scenario, so we better go ahead and get started. So, okay. Next slide, please. So as we've discussed in the previous slides, we are modeling 3 scenarios in the year ahead timeframe. So meaning we are assessing the reliability of 3 separate resource portfolios. So under the current RA construct, we have LSCs showing capacity up to their individual LSC obligations determined by their LRAs, PRM. So what the first scenario is trying to look at is what if, so this is a what if scenario, a theoretical one. What if the LSCs only show capacity up to their individual LSC obligation? And the way we looked at it on a system level. So collectively, what if we only receive or we only get shown the amount of capacity up to in the system obligation? So how would the reliability of the CAISO balancing area look like? So scenario 1 is more of a theoretical, hypothetical like scenario. So moving on to scenario 2. So historically, LSCs collectively, they've shown they were like long on their capacities. So so if you look at it on a system level, we've been long during almost most of the months in capacity above that month's like, obligation. So scenario 2, what it's trying to achieve is, okay, what if we model that a little bit of excess like each month is based on what we've seen historically, and we've looked at the past like 3 years, 2022 to 2024, and seen we saw like each month how much on an average we were long in capacity of like the area that was shown. So we tried to create a resource portfolio based on those historical patterns. And for 2025, I mean, we don't know, if LSCs, like would be like will be inconsistent with like what we've seen 3 years. We've seen some months in the past like 3 years, they were more long than like a little bit less. So, but I think for this scenario, what we're trying to do is we're just like looking at like an average. But who knows? I mean, for next year we might be in a really good position, like lengthwise, collectively. So that's what scenario 2 is trying to like assess. So what if each month we receive extra and shown capacity to the CAISO, and how would the CAISO balancing area look like under scenario 2's resource portfolio? And then finally, the all RA eligible scenario takes into account all of the RA eligible resources based on the NQC list. So what if all of those resources are contracted and shown to the ISO? Now, how would the CAISO area reliability look like? So if you look at from scenario 1 to 3, scenario 1 is more of a conservative scenario, and scenario 3 is more like an optimistic scenario. And what we're trying to achieve with these 3 scenarios is we want to see progressive like levels of reliability based on different levels of RA supply on the system. So that's our main goal here, and I think that's what I'm trying to show in the next slides as well. So based on like the assumptions, on the assumptions on this slide, we've simulated the probabilistic model in Plexos for those 3 different resource portfolios to calculate the LOLE level for each of those scenarios. And this slide on a high level shares the assumptions we've considered for each of these scenarios. So scenario 1 and 2, they're both like based on the resource list for both of the scenarios is based on the LSE survey that we've conducted back in May. We've received a good amount of feedback on the LSE survey, which I'll share the summary results probably in the next slide. But we also supplemented that list. We also supplemented that list with like 2024 LSE plans for LSEs who haven't like responded to the survey. So the basis of the resource portfolio for scenario 1 and 2 comes primarily from the LSE survey from the year-ahead timeframe, which is 2025. So for the all RA eligible scenario 3, like I mentioned, it looks at all of the eligible RA resources, and we've sourced that list from the latest available at that time, which was on June 14th, the NQC list. And then we supplemented that with any expected like additions and retirements. And we sourced the expected additions based on like new resource contract from the survey. So we didn't want to be overly like optimistic and like include all of the resources from our like that are like, probably in that final phase of like COD. I think then we would be very overly optimistic. So we decided to just use the new resources that are shown in the survey that have been contracted. So to the extent that there are new resources in 2025 and contracted but are not in the survey, this modeling exercise wouldn't capture those resources. So the portfolio, moving on to the portfolio section, the resource portfolio. Again, scenario 1 and 2, the mainly are using the shown RA resources. The only difference between these 2 scenarios is the level at which the system level capacity is capped. So scenario 2 has a little bit more extra than scenario 1 for each one based on the historical surpluses that we've seen, the month ahead surpluses we have seen. And then again, for the all RA eligible, I think I mentioned this during the input and assumptions section that we are using the eligible resources from the NQC list, and we also include energy only solar resources, which are co-located with battery resource and that support on-site charging in this scenario. Coming to imports, I think this is a good, like an important distinction between these scenarios is for scenario 1 and 2, we've relied on the shown capacity from the survey, primarily from the tie generators, from the pseudo ties, but for non-resource specific imports, so shown capacity on the ties, we've used a value from like an average value from past like 6 years to model, like shown capacity on the ties, because we haven't received like robust information, especially on the ties from the survey. So we use the historical data for our imports on the ties. But for shown capacity on the tie generators, specifically, we've used the survey data. And for the all RA eligible scenario, the imports, they are capped at a net import limit, which is restricted to 5,500 megawatt during the net load peak hours 16 through 22, during the summer months of June through September, and during all other hours, the import limit, the net import limit is set at the max import capability, which is around 11,665 megawatts. So one like distinction here, based on the data at least during the summer months, if you look at like collectively the imports that are allowed in the showings scenario 1 and 2 are a little bit more than what's allowed in the all are eligible. So what I mean is, for example, in September, in scenario 1 and 2, the amount of RA imports that we're considering is close to like 7,000 megawatts, because that's what the shown values like indicate based on the survey and like the past historical data. But in the all RA eligible scenario 3, the imports are like capped at that 5,500 megawatt limit. And the idea here is for all the capacity that is shown, we assume that they are firm imports, and they have allocated MIC, and they are firm, and they will be delivered to the guys. So that's our assumption there for imports for these 3 scenarios. And as we discussed, average hydro conditions throughout for all these 3 based on the 2018 hydro year. And another important distinction in terms of outage assumptions is for scenario 1 and 2, which are mainly based on the showings data. We're only modeling forced outage rates. We're not modeling any maintenance rates or planned outages, because our assumption is that all of the planned outages will get substituted. So we didn't model planned outages, although we are like, aware that not all planned outages get substituted, but for the modeling purposes, that's our assumption, that all of the planned outages in scenario 1 and 2 are substituted, so only forced outages are modeled. But when you're considering all our eligible resources, so we are modeling the entire eligible fleet, so it's important to capture both forced and planned outages. I'll stop here and take any questions, comments, if we have any.
We have a question here in the room, Sai.
Yeah.
Steve Keen, Edison. With the imports, how do you make a distinction between like the stuff that's dynamically connected and just the regular RA imports?
Yes. Yeah, we do have a distinction in the model, as highlighted in like the starting slide of the model topography. We consider the RA on the ties as like economic imports, and we use that to model, and anything on the dynamic imports and from pseudo tie generators, we model them as individual generators for the most part, and then solar and wind, they're modeled based on profiles.
Yeah, Thanks.
We have one more in the room.
Carrie Bentley with the Western Power Trading Forum. I'm sorry, Sarah, I heard a lot of the import numbers and I was trying to write them all down and I got a little twisted. So if I could just repeat back what I heard and can you tell me if I'm kind of understanding? So first, when you say imports, you mean both resource specific and non-resource specific resources. So this is a total number of all imports you're allowing in. And then when you're talking about both scenario 1 and scenario 2, you're capping them at the monthly historical average between 2019 and 2024.
Yes, for
Right?
scenario 1 and 2, the monthly historical only applies to the non-resource specific.
To the non-resource specific, to the non-resource specific. Okay. So then that number you gave, that 7,000 megawatts, is that a total number or is that for non-resource specific only? That's a total number.
That's a total between, resource specific and non-resource specific, yes.
Okay. Plus resource specific. Okay. And then you gave 2 other numbers, and this is where I got really lost. You said something about 11,665. Is that right? What did that number come from?
So that net import limit is applicable to scenario 3. So that's based on the MEC number, and that's only applicable during those off-peak shoulder months. But the 5,500 limit in scenario 3 is applicable during our ending 16 through 22 during June through September months. So the summer months have a different limit than the non-summer months in scenario 3.
Gotcha. And Noah just showed me that was a reference back to that earlier slide. So that I tied that in now. Okay. Then I think I'm understanding. So then my question is, when you're doing these different scenarios and you're assuming these different import levels, I think that makes sense to have a difference between the showings and the all RA eligible. And I think the all RA eligible to me now is making sense too, because you're just basically saying all imports eligible based on the MIC. But then when you constrain it to the showings, I think I have the same kind of point I made about the average hydro conditions. And that's if you're using this to determine what you need on the system and what's actually available to California. The rest of the West is getting tighter from a capacity margin perspective. And I'm wondering whether it actually makes sense to use that average number or whether to use some sort of trend or to look at, WEC studies on availability within these scenarios. And I think it would be helpful to see, and I know you have this data because you presented it previously, Aditya has, on the 2019 to 2024 import showings. And if I remember, they went way down and then they just started to tick up again, right? So maybe, we could think a little bit more about what makes sense there. And I don't have a good proposal off the top of my head, but I feel like average is probably the wrong way to go since we do have good indicators of WEC-wide excess availability into California.
Yeah, the portfolio that is going to be in scenario 1, for example, is not driven by the imports only, it's driven by the obligation. So the load plus PRM, that obligation at the LSC level drives what amount of capacity. The import is dictating what type of capacity that is going to be there in the model.
Gotcha. That makes sense. So, and you're pulling, and your quick answer earlier was to calibrate the models. Later on, you're pulling out imports anyway.
Yeah.
So maybe as long as the import set resource type looks kind of like the internal resource set type, it doesn't really matter what numbers you're using for scenario 1 and 2. Is that right?
Say that one more time, please.
If the resource types are approximately the same between imports and internal resources, and you're just pulling out imports to calibrate your model to get to that 1 in 10 ultimately, then I don't have to really worry about the aggregate number of imports. it more matters what specific import resource types you're pulling out of the market to get to the 1 in 10 eventually.
Yeah, this is a non-resource specific import, so it looks like flat availability across.
Oh, I thought you
Yeah.
said it was both. It was both the
So
resource specific and not
the
resource
limit
specific.
is telling how much, that is 5,500, for example. That 5,500 comes from three sources. One is known resources, that's Palo Verde and Hoover, Intermountain Coal. And then the other comes from non-resource specific resources. Collectively, 5,500 megawatts can flow into that system is how these are being modeled into CAISO BA.
Under all the scenarios or just all RA
Scenario has
eligible?
its own value, but that
Yeah,
in one
okay,
example,
okay, yeah,
that's
yeah.
how we think
Yeah.
about it, right? So if the LOLE was less than 0.1, and if to get it to a 0.1, what we did is we backed out these imports to mimic constrained capacity. And
I
then
see, but you
what-
backed out the non-resource specific.
Yeah.
Gotcha.
Yeah.
Okay. And you never had to actually dig into the
Which
resource
one is, yeah.
specific. Okay.
But when it's an import, right, it's non-resource specific, it looks like full available all the time up to that limit. So it can be coming from different resources depending on the hour.
Interesting. So you're not modeling it just during the AAH hours, the availability, the 5 hours. You're modeling it 24 hours fixed across the whole period.
5 hours, that 16 through 22 has 5,500 megawatt limit. But for the other hours, you go all the way to the MIC, which is the max import capability that is calculated. That is 11,665.
That's interesting because I don't think that's aligned with the RA bidding obligations for those resources. Right?
So
Someone check me on this. It's been a while.
yeah, I think with respect to RA
Yes,
bidding
we could say that for
obligations,
scenario 3A.
yeah.
Yeah, we could say that. Sorry, I didn't mean to get too far ahead.
Okay. Think if there are not any more questions, we could probably move on to the next slide.
Hey, Sai, this is Ansel.
Yes, yeah,
Just before we move on to the details of the scenario, the portfolios and the scenarios, I just want to kind of reiterate what you shared on the previous slide, that scenarios 1 and 2, we're thinking of them as kind of a reference point or a yardstick, whereas scenario 3 looks more like what you're familiar with in our summer assessment, where it looks at the entire BA resources, and that would be what you would use if you're looking at counting rules and setting a PRM. The point of those systems are to allow flexible procurement to reach a certain margin of supply. And so that's when you want to look at the scenario 3 situation where you have the entire fleet available to satisfy those requirements. So I hope that's helpful framing. I think scenario 1 and 2 will give kind of a picture of how things look with just shown resources, which is not what the ISO has available to us in daily operations, but it's just a helpful reference point.
Can you say that again? Sorry, the
Yeah.
part that I completely missed was what you were, when you were making this distinction between the two and which one you would use to do the PRM and counting rules.
Yeah.
Can you say that part again?
Can we go back 2 slides and then I'll hand it to Aditya?
Yeah, scenario 3 will be used to set default counting rules and default PRM. Because there we are looking at default rules. We want to account for all resources that is available to the ISO BA, and all resources and their capabilities can dictate how the ELCCs and whatever we calculate, we determine the default rules to be. Scenarios 1 and 2 is more informational and I don't want to call hypothetical, but those are hypothetical scenarios. But the reason is this. In scenario 1, for example, we are only looking at resources up to the obligation, but we all know that there are other non-shown RA resources in the system. There are energy-only resources. There are other imports. There are what is it called? The resources procured under effective PRM at the PUC that go 17 to 21, 24.21.5%. So there's a lot more other capacity that is in the system. So because our lens is the BA reliability, we are looking at scenario 3 for all the other analysis.
My quick response to that, I think that where I get confused is because the way I think about RA availability to the CAISO balancing area is RA that has not been committed to an external balancing area. And if you're counting on, for example, 11,000 megawatts on the non-peak periods, that's making the assumption that that's not dedicated to RAP, right? It's not committed by a RAP entity that hasn't been committed to another California balancing area. I think that's probably a big overestimate on what you could count on for the CAISO BA. So I think it doesn't make sense to me to quite use all RA eligible to determine the PRM accounting rules. I think you probably want to limit that set in some way, because otherwise I think you're going to get the wrong resource mix, and you're going to overcount these flexible looking non-resource specific imports that will change the results pretty considerably.
Yeah, I think the results will, when we come to that, we should probably talk about it one more time, but it is not binding. The import 11,000 is not binding. We don't need to go even to 5,500, 1,800 is the surplus, right? So 3,000, something, that number is what is binding from an import standpoint. So.
All right, thanks. I think I'm getting a better idea.
Okay.
Yeah.
Thanks. Perry?
Perry Servideo CISA, just because you mentioned it, can you, and I know you probably have a slide on it later, but are the strategic reserves considered all RA eligible in scenario 3?
No.
They're not. Okay. Okay. I thought I heard you say they are. Okay. So that then can you go to the next slide? I just wanted to one more time, maybe it wasn't, yeah, this one. Maybe one more time, Sai, if you could describe the rationale for why the planned outages are not modeled in scenario 1 or 2. It has to do with the substitution rules, but can you just cover that one more time?
Yes, yeah. So our thinking was, okay, for the showings scenarios where, like if the shown capacity is an outage, currently the LSC has an obligation to replace, if it's unplanned outage, to replace it with a replacement or substitute it with replacement capacity, right? So for those two scenarios, at least from a modeling standpoint, we said, okay, it might get really complicated to assess and analyze that and reflect in the model. So our assumption was, okay, we only model forced outages for resources, and for planned outages for shown capacity, we just assume that they will get replaced with substitute capacity.
Okay, so the logic is if it were not replaced, it would have been converted to forced and therefore covered in the forced outage rate?
No, so if you looked at the forced outage, the outage table, so we have like maintenance rate and forced outage rate separate for many of those resource classes. So what we did for the showings scenarios is we turned off the maintenance rate and we only created those 500 random samples based on the forced outage rates.
Let me try it a little differently, Perry. The hypothetical scenario 1 here, if the ISO were to rely only on the current shown capacity to operate the grid and everything else is turned off because they don't have any performance obligations, what is the reliability of that fleet? Which means you don't have to worry about planned outages in this space, because in the process, the current process, if you have to take a unit out on planned outage, you provide substitution. So we are assuming the same thing will be true in this case. So we're not worried about a planned outage replacement.
Yeah, and if I had planned on doing an outage for 2 months, and then I was not able to get substitution, it would be converted to a forced on me anyway. Then it would show up in the forced outage rate in which you're modeling. Is that the logic there?
That nuance was not modeled here.
But I think if you want to capture that, I think then you need to update the time period in which you're looking at the forced outages.
Mhm.
So it syncs up with that current rule, because the early 2010s, there are different policy related to substitution. So if you're pulling forced outage rates from back then, there's a little bit of that's a little bit out of sync, I think. So when you go to update the forced outage rates to something more recent, I think you'll see that dynamic sort of play out, where then you can kind of ignore the planned outages and assume that they've either been replaced or converted to forced. Because people are going to take outages, right? You got a maintenance outage, you can, okay, don't substitute it, still take it. CAISO is going to see that as forced if you didn't replace it.
Hey Perry, I'm not sure it'll sway the LLE significantly enough on a whole year basis by putting in planned outages into scenarios 1 and 2.
Yeah, no, I don't mean to suggest that we should put planned outages in scenario 1 or 2. That's not what I'm saying. I'm saying I think this works as long as the forced outage rate that you're modeling is correct, and therefore captures what had been thought of as planned, but then had to be converted to forced. I would still consider it a maintenance outage, regardless of if CAISO calls it planned or forced at that point. Yeah, okay.
If I have to repeat the way I understood Perry is saying the forced outages modeled in 1 and 2 should be a tad bit higher than what's modeled in 3.
I don't want to say how much higher.
Yeah,
I
tad
don't
bit,
know
whatever.
magnitude. I just know that the time period that you look at for establishing those forced outage rates should align with the time period in which the policy was that you had to replace planned outages. Yep. Thanks.
Yep. So also, like, if I can add, thanks for adding a bit of context there, Aditya and Ansel. If I could add, yeah. So if, for example, let's say planned outages the LEC was not able to substitute that, and then it was eventually converted to the forced outage. Maybe if majority of that's happening in those like shoulder months, when the resource majority of the resources like take planned outages, and we're not seeing, it wouldn't like materially impact the LLE results too, because we're not seeing like that many like loss of load events in the shoulder months. We did see some jumping ahead here for scenario 1 and 2, but it wouldn't like materially impact.
That's fair. Yeah, that's fair.
Yeah, thanks, Perry. So moving on to the next slide, unless we don't have any more questions. Yeah, I thought we will be strapped on time here, but I think we have the rest of the day. So, all right. So I think we've mentioned this in the past slides, that the probabilistic assessments or the modeling that we're doing right now, it only measures the potential to call on the emergency measures than actual like loss of firm load. So when I say emergency or contingency measures, these are the state-funded programs administered by CEC, CPUC, or DWR, and the main one there, the ESSRP, the SR, which is part of the Strategic Reliability Reserve Program, and the OTC units, which are part of that program, are not modeled. So all of those Alamitos, Huntington, and Redondo units, yeah, they're not modeled in our analysis. And also, like Aditya mentioned, CPUC has also like approved an effective PRM of 1,700 to 3,200 megawatts, about the 17% PRM in 2025 summer months. So it's almost like 46.5% above the 17% PRM. So to the extent the resources contracted to meet, that effective PRM is in the service, we will model those in our study here. But if not, we will. That supply is excluded. So yeah, I think those were the points that I want to make here on this slide. See, okay, so moving on to the next slide.
Hey, Sai, sorry to go back to it just one more time, but I think there's a important note, and we don't have to debate it right now because it's more of a policy note, but just
Can
the
you
note
go back
is that
to
if you're not,
47?
yeah, where we were just talking, I think the note is, or it was 46, I guess, but the note is just that if we're not seeing a material impact of that outage in the off season, in the shoulder seasons on LOLE, there might be room there to say maybe we shouldn't have a policy that requires planned outages be replaced, or we don't need to be replacing them if we're flush in excess capacity in those times. But maybe just a note to take over to when we get to the policy phase. Thanks.
Thanks for the commentary. All right, so moving on to slide 48. Next slide, please. Yep. Okay. I did present this slide or version of this during the June 18th workshop. It's basically summarizing the results from our LSC survey. The stack bars here show the survey data and shown capacity values by tie generators and iTies. Also other category for which we couldn't identify a resource ID in master file. But almost 7 load or LSCs that cover 72% of the CAISO balancing area load has responded to the survey. So that was really good data that we received in the year-ahead timeframe for 2025. So this graph just stacks that up and just compares that to the 2025 estimated obligation, which is caveat there. It's the peak hour obligation calculated using the IPR forecast for 2025 times the individual LSC PRMs. So we've used the 2025 PRMs that we've received from the survey, and for LSCs who haven't responded, we've used 2024 PRMs for them, and then any credits to come up with that peak hour obligation, just to give a sense of what's the obligation and what's how much did we receive from the survey. Okay, so moving to the next slide.
We have a question in the room, Sai.
Steve Keen from Edison. On the survey, when people were putting in the NQCs, they were using the ELCC values from last year, correct?
If this is, the survey is for 2025. So for 2025, the counting rules for CPUC jurisdictional entities were slice of day counting rules. So exceedance values for solar and wind, I would say.
No, but when they provided the survey, they should have used 24 values.
Okay.
Right, because that time 25 NQCs were not available. But I think the next couple of slides, I will show how we adapted those things to adjust for exceedance values.
Yep, yeah, that's right. Yes.
Can you say that again?
So, yeah, I will let Sai finish 2 slides and then I will talk again, if that's okay. Yeah, thanks.
All right, so this slide kind of just
Sorry,
summarizes.
Noah has a question.
Okay, yeah.
Real quick,
Go
sorry
ahead.
about that. What do you mean by estimated obligation peak hour for 2025? Is that based on not a CEC IPR, or is that, can you just talk about the estimated obligation wording?
Yes, yeah, the reason I put estimated in there is because by the time when we're doing this analysis, we haven't received LSC specific load obligation from CEC. So we just kind of used the load share ratios from 2024 to determine like individual LSC like obligations to that 2025 CEC forecast. So that's why I said estimated. I mean, it wouldn't be that off, but
right. But this is on an aggregate level, right? Why would individual LSC specific load share ratios matter in this manner?
okay, so because the estimated obligation there, the way we calculated that, and it includes, yes, for load, you could take it on an aggregate level, but when you take into account like the PRM sets on an LSC level, right? So that's why we first calculated the obligation on an LSC level and then aggregated it up. So load obligation per LSC, PRM per LSC, credits per LSC. And then we did that for all of the LSCs and then aggregated it up. So yeah.
Okay, so but you are using the latest IPER to which the 2025 obligations are set on.
Yes.
And then, okay, appreciate it. Thanks.
Yeah. Okay, so yeah, this slide shows the aggregate and the incremental like resource portfolios as we go from scenario 1 to 3. So the green bars here show the aggregate resource portfolio modeled in scenario 1, which is showing capped at the obligation scenario. And then anything incremental that we're modeling above that capacity is in scenario 2, which is all showing based on historical pattern. So like I said, scenario 2, the intent there is historically we've seen on a system level, we are like long in shown RA capacity. So we're trying to capture that in scenario 2. So we just gave, based on levels similar to historical levels, just gave a little bit more capacity each month to reflect that, that scenario. And then finally, in scenario 3 is again like incremental, how much more capacity they're modeling in scenario 3. And when you add that like extra like import capability, especially during those the shoulder months or non-summer months, you could see the all RA eligible scenario has a lot more capacity in those shoulder months, but it's a limit. We don't use like all of that limit in the all RA eligible scenario in those summer months. So at least from the graph, at least I think it might be a little bit overstated for the scenario 3, the amount of capacity that we're using the model. And I think one thing I want to point out here is, before I move on to any questions, is as you can see, the showing capped obligation, as the namesake goes, they should be capped, at that orange line, right? But which, for reasons for which I'll go into depth in the next slide, and I think we'll have a discussion there, is that obligation lines based on like peak hour. So this portfolio here is for scenario 1. So this is based on, it's the same green bars in the previous slide, but just broken out by fuel type. And then the same like orange line, but here it's the blue line for peak hour obligation. As you can see, the resource stack here that we're considering in scenario 2 is like exceeding that obligation amounts. And the reason being, if we go back a couple of steps, the data that we've received from the LSC survey and some of the data that we had to like supplement using 2024 LSC plans for LSCs who haven't responded to the survey, it resulted in like showing capacity like well in excess of like the obligation. So in order to create a resource portfolio for like scenario 1 and also for scenario 2, we had to adjust the capacity down. So we had to find a way to trim like the capacity to be able to create a resource portfolio for these 2 scenarios. And the graph here shows the resulting portfolio after we have done those capacity adjustments for each of the months. So the capacity adjustments were mainly concentrated or mainly done to nuclear, gas, and storage resource types. I mean, we've used historical showings data as well to ensure that our capacity adjustments are in line with what those particular resource types have shown, like in the past on an aggregate level. But in order to do these capacity adjustments, our goal was to meet not the peak hour obligation, but 24-hour slice of data requirements set under like CPUC. I know we have CPUC jurisdictional entities and non-jurisdictional entities, and those counting rules are only applicable to CPUC jurisdictional entities. But I think as we're doing this and as we dug into all of those rules, it was getting quite complicated. So we applied the same set of counting rules to create a multi-hour stack to determine the resource portfolio for each month. So if you go to the next slide, and then I can take questions on how we came up with the resource portfolio. So this is a resulting stack analysis for January, for example, using the CPUC slice of day counting rules, so exceedance for wind, solar, and then the rest of the counting rules are consistent with CPUC's methodology. And then the resource stack here is meant to meet the 24-hour obligation determined by that load plus 16.7 PRM. So the 16.7 PRM, the way we calculate that is, okay, we have 17% for CPUC jurisdictional entities, and then we have 15% for majority of the others, and then we have, I think, 10 or below for I think 3 of the list. So we calculate a load weighted average PRM, which came out to 16.7. So instead of doing capacity adjustments to the peak hour obligation, we did capacity adjustments to this load plus 16.7% PRM. And then that's the reason, I think in previous slides, when you stack that up for each month, it exceeds that peak hour obligation line. And I think one other point that I would like to make on this slide is we've also taken into consideration when making these adjustments is if there is excess battery discharge in those peak hours there, we use that consistent with the slice of day rules. We use that excess battery to fill up any shortages that we've seen in those white spaces that you see, those morning ramp periods, also later during the day, and that's how the resulting stack will look like on the right side. So we did also account for how to redispatch, if you say, of storage in doing those capacity adjustments. And one final point I would like to make before I take questions is the way these capacity adjustments are reflected in Plexos is we're not trimming individual resources, except for nuclear. We are taking out Diablo there, but for batteries and gas resources, we have enforced a capacity constraint on the technology level or on the resource class level, such that there's only this much amount of capacity available, X amount of capacity available in a particular month, and then the model optimizes based on the available resources. And so we haven't individually cherry-picked resources in order to implement those capacity adjustments in the model. We did also explore another route instead of from a supplier route, to do the adjustments on supplier route, is to model a flat load approach, but that did kind of seem like an overly conservative approach. So we decided to do it based on the 24-hour requirement, CPU size of day, counting rules, create a resource portfolio that meets these 24-hour requirements. Okay, so I see one question in the chat from Kai Neves. What's the origin of the 16.7 PRM on this slide? Yeah, it's load-weighted average PRM of all the LSCs in the CAISO area. So 17% for CBC jurisdictional entities, and then 15% for the majority other LRAs and then their respective LSCs. And then the remaining PRMs for, I think there are only like 3 LSCs with 10 or less PRM. So yeah. Okay, I have another question in the chat. Please confirm that the PRM used in the portfolio adjustment for CB 17% does not include the effective PRM required for the 2025. So it is a load-weighted average PRM. So we're using just one PRM, so 16.7% for all of the resources combined from all of the LSCs. And with respect to your question on effective PRM, so as long as, because for these scenarios, we're using the survey data. So as long as the resources are contracted to meet or contracted for that effective PRM and are included in the survey, we'll model those in the study. But if they're not included in the survey, then we're not modeling those in the study.
Yeah, but only up to that 17%.
Only,
so
yeah,
we are not
only up to
modeling
that 7.
everything.
Yeah.
Yeah.
Exactly. Yeah.
Hi, there's a question in the room. Okay.
Carrie Bentley with the Western Power Trading Forum. So going back to the intent of this scenario, I thought that was really useful the way Ansel summarized it. And in my mind, the intent of this one was to ensure in a loose way that the aggregate of the LRA's planning reserve margins leads to a 1 in 10 sufficiency in the CAISO balancing area. And so, you're not, scenario 1 is not looking at historical showings. It's just saying if we take, the requirements I've given and we use a good estimation of what capacity we're getting, are we meeting a 1 in 10? And I think, and this is going to be very nuanced, I think then what you're doing to recreate the slice of day showing and removing capacity probably will not then give you a good estimate of whether a slice of day planning reserve margin will translate to adequate capacity in the CAISO, because inherent in that slice of day construct is an inefficiency in which all LSCs have to procure to their individual load. And when you stack all those up together, you will always end up with over procurement by design of the slice of day program, which is why when you translate, the peak to the slice of day and then back again, you have to remove that capacity, because you will always end up overshowing between a slice of day construct when you translate it to a PRM. Not a PRM, to a peak program. That translation leads to additional capacity. So I think it's inappropriate for you to remove it, because that excess is actually inherent in the slice of day program, and the CAISO can quote unquote kind of count on that inefficiency and slack to provide the excess capacity. Now, you could quibble about how much the LSCs will be able to trade away that inefficiency and that kind of over procurement on an aggregate level, but it will never come down to 0. Did you follow? I know that's a super nuanced point.
The caveat that I want to highlight there is we did not remove capacity in the traditional removing capacity sense. We made sure that when we only focused on the peak hour, for example, we come up with one set of resources. And then we said, use that set of resources and show me a 24-hour slice of day.
Yeah, keep going.
Yeah, sorry, 24
I'm
hours.
gonna argue with you, but keep going.
Yeah.
Yeah.
Yeah, so it meets at 24 hours. If it doesn't meet the 24 hours, then we know we will be getting more resources, and that's why we had to go back and add more. That's what Sai was trying to show. When you focus solely on the peak hour, you get less, but if you look at the slice of day, you get more. So we kind of captured that. So if you go back to slide 49 in there, but 48,
Yeah.
that I'm bad with colors, but yeah, whatever this orange line is, the line is calculated in the obligation in the peak hour, but then you get more than what is in the peak hour. So exactly what you're saying from different resources.
So it sounded like to me, oh, go ahead, Noah.
I was going to ask, isn't the green column based on what LSCs have submitted to you as far as a potential showing goes?
That would have been true if we got 100% survey response rate. We only got 72%. Then it becomes a hodgepodge kitchen soup. Then you put that, then you have to estimate for the remaining 28%, and you put it together. Some LSCs have shown more than their obligation, as though it will be available for all the months, which is not what we've observed in history. So that's where the second scenario came to life. We were like, okay, shown, but if you show me a little bit more than what you've historically shown, if I assess that fleet, what's my LOLE going to look like?
But in your inputs and assumptions document, you have capacity adjustments by scenario.
Yes.
Right. Table 4.2 has adjustments for nuclear, as you've said, nearly 4 gigawatts of storage and another 1,000 megawatts in January for thermal. What are those adjustments? But those are adjustments down, right?
Yeah, because we started with a scenario 3 portfolio.
You started with 3.
Yeah, to get down to scenario 1 representation.
Yeah, I think, I'm with sort of Carrie's thought process here is the estimate, potentially the estimated obligation that you have is the wrong obligation essentially to begin with, because the 17% plan reserve margin on the CPUC side is sort of more specific to slice of day and not a peak-based program.
Correct.
And therefore, in order to represent this chart on a peak-based program, you have to convert that 17% into a peak-based PRM.
Oh, no, sorry, I mean to clarify there. So what happened in this chart is we put slice of day kind of exceedance values for your wind and solar. So every hour you have an individual production profile for renewables. You have your thermal and nuclear available 24 out, which is what the CPUC slice of day adjustment would also, a slice of day program would require, would show, and then storage can be optimized in wherever you need. That's why on high level, that's what this is trying to do, and saying every hour you need to show me at least 17% of that hourly load value exists with that portfolio.
Yeah, so this is my point. So it looks like, and maybe this is not what you're doing in the model, but based on slide 49, it looks like you're exactly meeting that 17%, right? And my point is that that will never happen in reality. In reality, you will always have more capacity shown above that line. So when you do this translation, you should allow it to be above that line and then translate it back to this green bar. So my concern is actually not that the green and the orange don't meet, but that the green bar should be even higher above that orange bar, because it looks like you're limiting the obligation stack to exactly 17% on page 49. Does that make sense?
Yeah, quite possibly. But you have to make an assumption. So now I have to assume how much more that could look like. And that's why the middle scenario is trying to say, hey, if I give you more in bulk, so I think those charts are also there on the following slide. So you can see a lot more is available from 54 onwards. So if you go those stacks for every month, you can see a lot more resources than that. That could be a
So there's two things that I think occur. One, and this is the problem with using historical data, which is pre-slice of day, right? Pre-slice of day excess showings were for completely different reasons than post-slice of day excess showings, which just has to do with pure translation, right? So I think neither of these amounts are quite getting at what we would expect to see. All of that said, this is a planning exercise and it's loose and we should squint our eyes a little bit and I'm sure, we'll find the right answer over time. But I think using, as we go forward, and we won't have this data yet, but using the CAISO showings from this year and looking at the excess from slice of day and using that as a scenario will probably be more accurate than your scenario 1 and 2 here, simply because of that kind of massive shift change that we're about to undergo.
Stephen has his hand raised.
Yeah, I mean, this is the point I was trying to make before, because they're changing the way they do the counting. CPUC entities have to show you everything they show to the CPUC under the slice a day. That means my suspicion is because the numbers have, the values on how you can count resources for solar have gone from, like in September, it was 11% last year when you use the ELCC. When you use the exceedance this year, I mean, it's like 20 to 50%. So you're going to get the CPUC entities showing you an excess of, I don't know, I'm guessing like 30%. So you're going to have way more in that hourly counting thing than you should. The other problem is, though, that I think a lot of the other LSEs are going to use the NQC stuff that comes from the CPUC. So the NQC numbers that you put out that are using the exceedance values. So they're going to jump way up, but they're not meeting slice a day. So they're going to go from, counting 100 megawatt solar field as 11 megawatts in September to suddenly counting it as 40 megawatts. That's going to mean they can drop significantly the amount of other resources that they need. It's going to give you I don't know how to deal with it, but I think I think when we see the results that come in this year, they're going to be really different. And that's where I keep going back and forth. Your model is working on the peak stuff. That's not what CPUC entities are showing to. They're showing to a slice a day, so it's very different. And I don't think that, I suspect that the slice of day, 17% slice of day number, if you apply that to, if you convert that to what you're going to get, like I said, I think you're going to end up with a CPUC entity showing a PRM of, I don't know, I'm guessing, like off the top of my head, maybe 35%. And it's not that, it's not that anything's changed from last year. It's just that the way stuff is being counted has changed.
Yeah, true, but that is the peak hour PRM, right? That's why we are not focusing solely on the peak hour excess. We're looking at the 24 hours. You at least.
But you have a peak-based RA program.
Yes, but that is not what is being modeled here. We are only looking at, so let me back off way back. So we initially started with a peak hour obligation. So we take a peak load forecast and calculate 17%, and then you have a value there, right? We said what set of portfolio resources accounting for exceedance values in those hours, what does it amount to? Then we had that portfolio. But then you put that set of resources and dispatch it in 24 hours. We observe that it does not meet the slice of day requirements of having at least 17% in every hour for those entities. So then we had to add more resources or take down less. Forget the arithmetic there, but you needed more resources than what is for the peak hour obligation to ensure that the set of resources collectively can meet a 17% every hour.
But then what you need, I think what you need to make clear before you put anything out there is, there's a big distinction. the PUC entities are going to be meeting a 17% slice of day PRM.
Yep.
That's going to give you probably a 35 or 40% peak hour PRM. So when you do your calculations and you come up and you say, oh, we need a 30% PRM, okay, you can't say that that's what, okay, the CPUC should adopt 30%. No, then you got to do the reverse engineering to figure out what that means. I mean, that may be what those entities that are not using slice a day have to get. But that's not what the CPUC entities are going to have to get. And I think you need to, I'm worried that you're going to come out with a number like 30% and say, oh, this is what we need. And then it's going to get moved into the PUC and we're going to end up significantly over supplied.
Well, Steve, I'm not sure it's significantly oversupplied. I think this is Noah from Middle River. I think the ISO's default PRM is not a minimum PRM,
right,
as it has said, and therefore it's a peak-based program.
Yeah.
Right. And so you need to do that translation into the CPUC program. And Middle River has provided some of that information in comments for I think the 2026 LLE set. And you can go see that. I think here, unfortunately I put really very little weight on scenario 1 and 2. I personally have questions on why storage and nuclear were taken out first from the capacity adjustments by scenario. But it's just a little bit weird to me because I think that would change your production cost simulation models as well. I would really think the results of 1 and 2, you can see clearly in slide 67 that the 17 or 16.7% PRM is not reliable. You want to, all right, yeah. 0.782 relative of 0.1 LOE. I think what's more important is sort of looking at the ISO's scenario 3 and 3A, to which I have lots of questions on 3A because I don't understand. There's very little information on 3A in the inputs and assumptions.
No, before we get to 3A, I want to say a couple of things. The reason we took nuclear off in January and February is informed by historical showings. When you look at history, nuclear is not usually shown at shown at all in January and February. It's used for substitution resources, so whatever the other reasons are. So we were trying to mimic if the ISO only had to operate just the shown fleet of capacity. And I think the slice of day comments that Steve made are important to remember if you're only looking at it a peak hour, but the PRM is not coming from a peak hour here. We are looking at the portfolio's ability to meet an LOLE kind of a 0.1 target, right? So it is a kind of a different lens that we should look at it, and slice of day is a different mechanism. But the reason of showing 49 here is to say that our portfolio is not a hypothetical portfolio. That is could be a very real, reasonable portfolio. If collectively all you just showed is this resources, you meet your LRA, RA obligations with that resource fleet, with that set of assumptions. And yeah, Carrie.
Carrie Bentley with the Western Power Trading Forum. I'm wondering if there's a disconnect. So one, I think important to keep in mind what scenario 1 and 2 are for, and that's just to assess whether the CAISO balancing area is reliable. That's not being used for the PRM and counting rules.
Correct.
Like Steve, I think you made a bunch of good points, but I think that's about scenario 3, and we should think about it there. For 1 and 2, we're just kind of doing a gut check. All these different programs, when we kind of combine them, do we have enough capacity? And then I think where maybe some of the hang up is how you're creating the portfolios, because you used a survey approach rather than just taking like last year's showings or this year's showings. And so I think it's the ink up or the pull out that's getting, how are you getting that amount? And so I again want to reiterate that my issue is not exactly what, like, the methodology seems almost there, but I think that missing disconnect is just that a 17%, when you get showings based on that, your showings are going to be above that amount. And you have to figure out how much above that. And I think you're not going to be able to do that until you get an actual slice of day showing. And then my other just kind of caveat to that is the CPUC did put out that report on the test year, and they did show how much excess they received in every single hour. So if you want to move forward with this study before you get any actual results, you could just use that test year excess amount and take a look at that. But beyond that, I think I'm comfortable. I know I've said a lot in the beginning, but I think I'm getting more comfortable with how you're doing this.
Yeah, this might be the most stringent case of portfolio that meets all of the objectives of all LRA, RA requirements, slice of day, yada, yada, right? But in reality, I think we won't be in one for sure. We know it could be somewhere near 3, but yeah, the idea of showing all of these results is it is important to get full visibility of all resources. I think that's one of the ideas the key takeaways from this results. And obviously you can do a perfect backcast, but when you do for future looking, you have to make a ton of assumptions, and how much do I assume is always an interesting challenge. I think we should move on in the interest of time. We have 45 minutes. As long as we all are comfortable with the intent of the 3 scenarios, what are we trying to do? There obviously are many different ways in which we could study those portfolios. But yeah, I think Noah, and then we can move on.
Yeah, sorry. Do you intend to update your scenario 1 based on the year ahead showing data that you'll be getting at the end of the month?
No, because we looked at the year ahead. I'll tell you, there is a reason for that. We looked at the year ahead showings, and that also had a ton of excess in the showings in the year ahead time frame, but that is not binding. What is binding is what's actually shown in the month ahead time frame, right, from a resource standpoint, and that closely followed what the obligation set was.
But that's the whole point. You are going to have a ton of excess. You should count. Sorry, Carrie Bentley, Western Power Trading Forum. So I think that's the point Noah and I are trying to make, is that you are going to get a ton of excess with a 17%. With any PRM, you're going to get access of that from the CPUC. And so you should count that, even in this scenario 1.
In the year ahead showings, there is excess, but in the month ahead showings, there is not.
I bet you will get access in the month ahead showings.
Yeah, but that will be a function of the like resource accounting, and there is excess, and then that flips you get.
Are you also comparing the excess to a 90% requirement or the full 100% requirement?
Full 100%. No, I think we looked at 90, even 90 was much higher.
Sure,
I have
of
a
course.
chart for showing
you would
that.
expect it potentially be higher than the 90%, but going
way higher than the 100% is what.
Yep. Yeah.
100% of the 17% PRM. Whereas what Steve and Carrie and myself are saying, you might be because the peak-based program may need to be in the 30% plus range. Therefore, you're comparing apples to oranges.
Because we've changed the counting rules, right? We went from an ELCC counting.
Oh, no. We did not look at the year ahead showings for 25. We don't have that information yet. We were looking at historical year ahead showings that were based on a peak hour program. And even in the historical year ahead time frame that are due in October, right, Abdul? That are due in October, you have to show 90%, 100% of local, 100% of flex. Even that showings showed a lot more excess than what the obligation was. But by the time it comes to month ahead, that little slivers is the amount of excess that you typically see.
Okay, but again, let's different. Sorry, Carrie Bentley, Western Power Trading Forum. And I know we need to move on, but really quickly, I think it's important to categorize the excess. You have excess that happened historically for completely different reasons than you're going to have excess due to slice of day. Excess historically was really high in the year ahead and then almost completely disappeared in the month ahead. There was still some excess, but it was a very small amount. In the future, we're going to have systematic excess in every single month that we can count on. because when you add up the individual LSC obligations and the supply to meet it, that total is greater than the total obligation.
Yeah, that's a different problem.
And
That's
that's a
solely
diff-
based on accounting.
Yeah.
But that doesn't give me more resources is my point. I'm sorry, I'm looking at it from a resource standpoint. You're talking from the Abdul's
Yeah,
lens.
my point is it does give you more resources because they are going to show you more resources than, let's say you just had one LSC meeting one obligation, right? Yes, when you translated that to a peak program and you translated their perfect slice of day to a peak, you would end up with a certain amount of excess resources because of batteries, let's say, right? All right, so that's one overage. The next overage is due to the fact that you have all 36, right? 26 different LSEs meeting their own individual load shapes. And when you add up all that procurement, there's another overage on top of that. So there's that new overage, slice of day overage, there's the conversion overage, and then there's the historic overage that we've just seen because people have shown excess, notably SCE for who knows why. So you have to actually add, so that historical overage, I think is probably irrelevant now. And then those two remaining overages, I think you're accounting for one of them. You're accounting for that translation factor, but you're not accounting for the secondary overage, which is due to the fact that each LSC has to procure, and you're going to end up with systematic overprocurement. Does that make sense?
Yes. So the reason is it's hard for me to speculate what that will be and come up with a reasonable assumption that I can convince you all, right? So what we looked at was the most stringent case. If I just showed just enough to meet my requirement, this is my portfolio. But that's why we did scenario 2 with more. Scenario 2 and a 2.5 is probably what actually gets shown to the ISO based on those two different contributing factors to what the excess capacity might be.
Both of them seem low to me. I'll put this in our comments, but I think you should compare it to the test year showings. Like there was excess by like 8,000 megawatts in a lot of hours. It's a crazy amount of overage that I think you'll have to account for in your studies, even if it is kind of a guessy sort of number. It's a technical term, guessy.
In the interest of time, should we transition to the next presentation?
Yes. Yeah, one last thing I'd like to repeat because I don't want this thought to be lingering is the month ahead showings are binding showings. If you are, that is where the resources now have our performance obligations and must offer and bid insertion, RAIM, blah, 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 right? But when it comes to year ahead showings, that is speculative. So people are more historically shown excess there, and that excess does not translate. I think that is something that we should remember. If I focus on the excess, then I'm giving you a picture that is very close to scenario 3. But if I'm only getting shown RA resources, that's more like 1. So it is somewhere in the middle there. All right, thanks. I probably pass it back to Sai. I think we've had enough discussion on this one. So if you want to breeze through your sets of slides, Sai, we can go quickly to showing after that.
Yep. Yeah, sounds good. Yeah, thanks for that productive discussion, everyone. Yeah, I think this was our reasonable attempt of, like showing, like the progressive levels of reliability based on different RA portfolios, given like the speculative nature of how the 2025 year is going to turn up. But I think the year-ahead showings for 2025 will be due soon, so I think we can wait and watch. So okay, so can we go to the scenario 2 slide? So can we quickly jump, because the next set of slides just shows the resource portfolios for each month. So next slide, please. And then maybe 2 more slides. Just the multi-hour stack for scenario 1. Then next slide. Scenario 2, same thing. We did the same thing to get to this resource portfolio. The only difference is we added that historical excess that we've observed over the past 3 years in the month ahead showings. And that's the only difference between scenario 1 and 2, and the resulting resource stack is shown here. And the next set of slides are again the on how these resource portfolios are represented in the 24-hour stack based on the 16.7% load weighted PRM. So if we move on to the next slide. Yep, all the way, maybe 2 more. And then, yeah, next slide. And finally, this is the portfolio, resource stack portfolio for the all are eligible scenario. This is based on the NQC list, and any new expected additions in 2025 are captured from the LSE survey. And to the extent they're not captured in the LSE survey, those will not be reflected in the study. And then you can also see that max import limit shown by brown bars reflected. It's a limit, it's not like firm. So might be an overestimated here capacity shown in this stack here, but as you can see, it's 11,000 during those non-summer months and 5,500 during the peak summer months. But it's only applicable during the net load peak hours of our 16 through 22. And next slide. And I think that should be the end of the modeled scenarios. And going to the results, I think I can kick off the title, the high-level slide for the results, and hand it over to Shuping. So move to the next slide. Right, thank you. So what did we look at for these 3 scenarios? So for these 3 scenarios, we've already looked at the stack analysis results, which are the deterministic results. And the next set of slides, which Shuping will cover, are for the all RA eligible scenario. And we also looked at the probabilistic assessment for these 3 scenarios, and the next set of slides will cover the results for those. So for the probabilistic assessment, yeah, we did the 500 simulations, each 8760 hourly chronological modeling, and then we looked at different metrics, which I will cover in depth after Shuping has a chance to go over her deterministic results for the all RA eligible scenario. All right, passing it off to Shuping.
Hi, everyone. My name is Shuping Li. I'm a lead analyst for resource assessment and planning in Aditya's group. Now I will walk you through the scenario results from our multi-hour stack model. Next slide, please. Next slide, please. So the same approach we use in the summer assessment. And for the load forecast for this for the model, we use the CEC 2023 IPER 1 in 2 planning forecast. And most resources represented at resource level with the NQC value in every hour. And for solar and wind, we use the exceedance value that are derived based on the past 8 years of actual generation data for the 5 highest load days. For battery energy storage, the energy discharge is spread across the at-risk hours to smooth out the energy available to above the reserve margin. The total energy, the megawatt hour is assumed as a 4-hour total energy available for the battery. But we do allow flexibility to discharge that energy across at-risk hours based on the need. For the import, so the import is not, so every resources except the import are modeled at resource level. For the import, we use the intertie capacity that based on the latest 5-year historical average monthly showing. Similar to the summer assessment, we use an 18.5% reserve margin above the 1 in 2 load forecast for this assessment. Next slide, please. Okay. So Sai quickly walk you through the scenario 1 and 2. We do see some shortage in the morning and evening peak hours. But for the all RE eligible resources, we didn't see any shortage across the 24-hour for all the peak days of the year. And we do see with all those RE eligible resources, we can see significant amount of excess above the 18.5% reserve margin. Next slide, please. For the summer months like July, August, and September, we didn't see shortage, but we do see that depends on how you dispatch the battery capacity, the excess value above the peak hour could be small compared to other non-summer months. Next slide, please. For October through December, we see significant amount of excess capacity. So I do want to, can we go back to scenario 1 slides, that January slides? I do want to highlight a little bit things there. Go back to scenario 1, like way back. The January, the two graph.
I think slide 49.
Yeah.
Probably 51, I think slide 51, sorry.
Yeah, this slide. So so the 16.7 PRM is not what we think will actually happen. It's a proxy that allow us to theoretically imagine what the capped obligation would be. So that's what we are showing here. So in January, we do see if the battery capacity is not cover the morning peak hours, we do see some shortage there. But using that battery capacity exceed the requirement level, we run different cases to dispatch the battery, and there is enough capacity and megawatt hour there to actually close the gap for the morning peak, morning shortage, and some of the evening gap there. So so that will close the loop. We didn't see any shortage if we could dispatch battery in the most efficient way to close the gap. So that's the point I want to highlight here. Now I will pass it over back to Sai for him to present on the stochastic study results.
Slide 67, please.
All right, thanks, Shubing, for walking us through the deterministic results. So now moving on to the probabilistic results. So we have 3 resource portfolios from scenario 1, 2, and 3. We have 500 unique samples for load, solar, and wind, and outages for each of these resource portfolios. Then we ran those 500 8760 hourly chronological simulations for each of the scenarios, and we looked at certain metrics, which I will discuss at a high level, which will be useful in understanding the results that are present in the next slide. So next slide, please. Okay, I think most of you might be familiar with the metrics here, but I still want to on a high level, like go through each one of these. So the main metric that we look at is the loss of load expectation, the LOLE, and the reliability target that we are planning to is like 0.1 LOLE, which means a 1 in 10 like probability of having a loss of load or insufficient generation to meet load. So when we're doing 500 hourly, 500 iterations of hourly chronological simulations, that translates to 50 events. So when I say events, in this case, it's days. So we are looking for 50 events out of 500 years, if you translate that to reach to that like 0.1 metric. So for a portfolio to meet that 0.1 in our model, it needs to have 50 days with loss of load. And like I mentioned earlier, we are counting loss of load as any hour with a capacity shortfall, which includes all of these, like load following, spinning, non-spinning, regulation up, headroom, and then finally unserved energy. Or if any hour only has load falling up and non-spinning shortages, we don't count that as a loss of load hour. So one or 2 points to keep in mind when we're doing or when you're only calculating the LOLE metric is in our case or in any case, if the number of hours that have loss of load and are span or like multiple days, so if they're continuous and span like multiple days, in our model we count that as 2 days or 2 events. But although it's very rare thing to ours to pass like multiple days because it would be like off-peak hours on the next day. It's rare to have loss of load, but that's one distinction to keep in mind. And also, if there are like 4 hours with loss of load in any given day, or if there is just 1 hour of loss of load in any given day, we count that as 1 event. So that's why it's important to look at the other metrics, which is the loss of load hour, and then it's also called as the duration metric, and also the EUE, which is the expected unserved energy metric, which is the magnitude of shortfalls. So these 2 metrics combined with the LOLE metric paints us a complete picture of how reliable a given resource portfolio is. The 4th metric here to look at is surplus and shortfall. So like I said, when we run the simulations for a portfolio, we calculate its LOLE level. It could be less than 0.1, it could be more than 0.1. And the amount of excess capacity, for example, if that portfolio is less than 0.1, the amount of excess capacity that needs to be removed so that that portfolio can be tuned to 0.1 is the surplus megawatt. And the inverse is true for the shortfall. So if the portfolio LOLE level is greater than 0.1, that means it has more than 50 events. So we need to find like a shortfall amount. So we, to tune it to 0.1. So shortfalls are calculated as the additional capacity needed to reach 0.1. And then the maximum shortfall is nothing but in any given hour, what's the maximum amount of unserved energy that we've observed. And then the longest event in a given day is, did we see 4 hours continuously, like 4 hours of loss of load, or 8 hours, or it's just like 1 hour of loss of load? Is that the longest event? So I think when you're assessing a resource portfolio, it's important to look at all of these metrics in conjunction to paint a realistic picture. So moving on to the next slide. So this slide here shows the summary of all of these metrics to all of the scenarios that we've spent a lot of time discussing. So to reiterate, scenario 1 is showing cabinet obligation, where collectively on a system level, what if we only receive showings up to the individual LSE obligation? So that's like the most conservative resource portfolio, and it's a theoretical portfolio that we've assessed. And then the second scenario is what if we supplement the previous portfolio with a little bit extra each month based on the excess that we've seen historically. So how would that portfolio look like, and how would that reliability look like for that portfolio represented in these metrics? And then finally, the all RA eligible base case, which is just take all of the RA eligible resources, run it 500 times hourly chronological simulations, and what's the LOLE for that portfolio. And then 3A is nothing but when you tune that portfolio back to 0.1 by removing like excess capacity, what would, like the LOLE obviously is 0.1, and what would the remaining metrics look like? So because as we've looked at like how the resource portfolios like increase from scenario 1 and 2, it's obvious that the LOLE level from scenario 1 through scenario 3 goes from high to low. So for scenario 1, it's like 0.782, so greater than 0.1. So we observe like shortfalls there. Similarly, when you have a little bit extra each month, you can see how like how deep the LOLE has fallen from 0.782 to 0.308 in scenario 2. And like we mentioned in the previous slides, and I would like to reiterate that the loss of load metrics here only capture like our only capture like the intent of going into like emergency measures. It's not capturing the resources that are not reflected through effective PRM. It's not capturing non-shown RA resources, non-RA resources, or any emergency resources that are available for disposal. So I just want to make that point for the first two scenarios, and then for the all RA eligible scenario 3, obviously the resource portfolio, I think it has more capacity than the previous one. So the number of events, the loss of load events that you've seen here were like 12 out of the 12 days out of 500 years. So that translates to an LOLE level of 0.024. And in order to calculate the surplus, I know Lauren asked this question earlier, in order to calculate a surplus in this case, because the LOLE is less than 0.1, we iteratively took out import capacity. So in the scenario 3, the import value was 5,500, especially during the summer months where we observed like loss of load. So we removed iteratively. So we adjusted like 5,500 to like 4,000 megawatts, and then reran the simulation, and then saw how many events there were. If it didn't exactly equal 50 events, then we again like reduced that limit down until we reached that 50 events. So in scenario 3, the surplus amount was 1,810 megawatts. So when you remove or when you exclude 1,810 megawatts from the 5,500 like value from the net import limit, you would have 50 events for scenario 3. That's what 3A is saying. It's essentially scenario 3, but tuning it to 0.1 portfolio. Okay, I'll stop here and see if we have any questions, comments.
We have a question in the room.
Noah?
Yes.
Hi, Noah Tom from Middle River Power. So, okay, going to 3 Alpha, you said all you did was in June through September, was it September? Reduced the 5,500 down to about 3,200?
Yes, yeah, minus 1,800, yes, yeah.
with no other changes to the supply mix. So you're still at about 60,000 gigawatts or megawatts, I'm sorry, in January. Is that the right interpretation there?
So I think this would answer some of the questions in the chats too. But for scenario 3, we've only seen loss of load in I think July, August, and September months. So we didn't see any. So it wouldn't have like impacted any of those other months. Hope that makes sense.
Well, sure. It only makes sense on sort of on the holistic level, but when you start thinking about how this might inform the ISO's default planning reserve margin, potentially you would have to start mixing sort of a scenario 1 with a scenario 3 alpha, right? Because the 0.1 LLE is captured on an entire year basis. And so unless the ISO is expects to have all of the 60 gigs of capacity that you have in your table in 4.3 to show up in January, whereas you might have, where's your scenario? Yeah, where's your scenario 1 on your slide 69? If only the capacity that shows up that meets your planning reserve margin, you are going to surface loss of load events in January and February, right?
Yep.
Okay, so if that's the case, then 3 alpha isn't quite tuned yet for purposes of a sort of a default PRM determination.
So, Sai, I'll probably take this.
Yeah.
If you're thinking from a standpoint of monthly default PRMs, then yes, we have to tune it such that there are no events in January. So you have to have a different surplus amount, you take it out, and then
you could have events in January. I mean, because your 0.1 LOE is for the entire year. You're not
true, but then the PRMs will be higher for every. Right? If you get 0.01 numerically, then you have 0.12 in the end, which means some months have to have 0 to put it. Or you just agree with 0.01, but then you are getting more PRM in the summer months. It's a way of numbers, right?
Are you also then thinking monthly default PRMs in the ISO tariff?
No, I think if they're thinking monthly, that's when I need to do fine tuning to make sure I have just the amount of surplus to get no more than 0.01 in January, right? But then I calculate using the counting rules that we all agreed to what the default PRM would be for January, February, March, April. But right now we only did it for the most constrained month. If you get on an average, I don't know what this PRM translates to. If you hold that PRM across the 12 months, you should be fine.
I mean, I think we can if you want me to do that live, I'll do that live for you in a couple of minutes. You have all the data in here. That'll be somewhat insane, I think.
Mixed match of NQC, so you cannot use that directly. So
yeah,
we fell in the trap and we quickly woke up. So, all right, Perry.
Yes, Perry Servideo CISA. I'm gonna try to start from a place of what you did makes sense, but I'm kind of going the same way as Noah here. Is if you look at scenario 1, the question is did scenario 1 or 2 surface LOLE in months outside of the summer? And I think the answer to that was
yes. The next slide will actually help with that.
Yeah.
We go to the next slide, please.
If the answer is just yes, I trust you on that. So I think then the logic of just reducing imports in the summer because summer is the only place you saw it in scenario 3 doesn't make sense because there's some kind of solution between there in which LOLE could surface in a month outside of summer. Am I thinking about that the right way? That what I'm drilling into is, does it make sense to only reduce imports during the summer months in which you saw LOLE in scenario 3?
Because those were the binding months. right? If it was binding everywhere, then you have to do a different curve
Yeah.
of reductions, but because it was binding only in the summer,
Okay.
if you further constrained it, then if you were able to get to a 0.1, then that was good.
Okay, and it's still, the LOLE that you're reporting here is still just the annual
Right.
LOLE?
Yes.
Okay. And is that the only lever then that you guys used to do the tuning, just the summer imports,
Yeah.
no other changes?
We did not have to do any other changes for this portfolio. If the
Okay,
portfolio
because
was,
you got down to 3,200 or so and things were still good.
yeah, 30, like
Whatever it was.
3690.
That's because they were leaning on 60 gigs of capacity in January
Yeah,
to meet a 35 gig load.
yeah.
But that January portfolio has planned outages and forced outages also. So obviously you don't need all of that. That's why you have a different PRMs.
Yeah, it's semi-tuned,
Yeah.
3A.
Okay, and then just back on the previous slide, I think this is a little bit of a different topic question, but I was just curious how the amount of this other stuff in the far right column on the previous slide, how much of that is there and how does it compare to the max shortfalls that we're seeing in the other scenarios? You know, this is the stuff you keep saying, okay, in the emergency situation, we're not saying this is actual loss of load. It just means we'll call this other stuff. But if the amount of other stuff's only 3 gigawatts and you're seeing max shortfall of 8, we are talking real loss of load, which I mean, I know that's the point of the study, but I'm just more of a curiosity on that. Do you know offhand?
I think,
Can we go back one slide?
yeah, the non-RA, if I'm memory serving right from a summer assessment, it's about 1500 megawatts of energy only resources.
Okay.
And you have 2859 megawatts of OTCs that became last year, about 3500 of OTCs, I think total 200 megawatts of fast start, 40 megawatts of, now I'm counting everything, but yeah, we have, I don't know, 4
What's
to
the
5.
total? About five
Yeah.
gigawatts maybe?
But then
Okay.
you can have, yeah. What effective PR?
Including all of the strategic reserves.
Yeah.
And that's about
Yeah.
5,000 or 5,500 megawatts.
That's, yeah, good. And then you can also get more imports, emergency imports on the interties. So there is plenty there. Not plenty, but there is more access to external resources, assuming not
Yeah,
everybody is-
non-committed capacity
Yeah.
external to CAISO.
Yeah.
Okay.
Kevin, you
Yep,
were trying to
thanks for
say
that.
something, sorry.
Yeah, this is Kevin Head from California ISO. Yeah, just adding on to what Aditya was saying, there's also the effective PRM of 1700 to 3200 megawatts, which can be called upon if needed. It's unclear whether the resources that would be used for that are also counted in like the non-shown RA bucket that you had mentioned. So the accounting exercise is kind of challenging to do, but yeah, I think Aditya's logic was correct.
Steve?
Yeah, when you did these 4 scenarios, were you using the same 400 draws of the 500 draws? Each of them is running the same 500?
Yeah.
Okay.
So one clarification there. Yeah, load is the same, but for solar and wind, it depends on the nameplate capacity of solar and wind in each of these scenarios. So for example, I think the all RA eligible case has a different nameplate capacity for solar and wind than the showings cases. And I think I put those in the INA document, the difference in nameplate capacities.
Okay, there's probably a good reason for it, but one of the things that's getting me is when I look at the max shortfall in case 3A, you know, that's where you have the max shortfall.
Yep.
Even higher than in case 1. And I'm struggling to understand how that could be true.
Yes, I think we can take a look at that. But I think one difference that I could think of is like the imports in scenario 3 are restricted. I would say like much more during those summer months than in the showings scenarios, which are based on like the showings values. For example, I think I gave September as an example for the showing scenario. I think we were using 77 or 7,100 megawatts of total firm import capacity. But for the all RA eligible scenario for September, I think we were using 5,500 megawatt capacity. And I think that's just one piece. There might be other like levers as well that might be driving that shortfall in one single hour, maybe I think battery dispatch. But yeah, we are, like Aditya mentioned, we will be also like providing the 24-hour dispatch charts for like events like these to see more in depth of like what's going on during loss of load hours. So yeah.
Just add on to that in terms of why last case 8,000 versus the case one is 6,000. I think this comes back to the way we dispatch batteries is not restricted, so it could any hour could be different, and we didn't enforce any strategy in terms of the maximum show for 1 hour or average across different hours. So that could change this also.
Thanks, Wensheng. Just to drive that point home, I think the max shortfall column is a little, it's a little confusing in the sense of the first three metrics are more of an average across all the simulations, whereas the max shortfall is the worst deficiency in the worst single draw.
Single hour, single draw, yes. So it's not average, so it's
right.
And it's also not like optimized for minimum max shortfall right now is your point.
Yeah.
Okay.
Yeah, it could be in one of those 1 in 20 load sample. Okay, so yeah. All right, so I think moving on, I think we had some questions in the chat. Hopefully, I think our discussion answered your questions, Andrew. So we have the heat maps to answer your first question, and also the max shortfall question that we just discussed should answer your question number 2. So if there are no more questions, I think the next set of slides is dig into each of these scenarios showing these heat maps. So if we move on to maybe 2 slides. So this is scenario 1. As you can see, we've seen loss of load events in January and February, as well as in October and November for this scenario. And then moving on to the next slide, which shows for scenario 2. So once we add a little bit more extra, like each month, some of those loss of load events have disappeared from scenario 1 to 2, as represented by the heat map there. So February is gone, I think October is gone, and also some events in November are also gone in scenario 2. And the loss of load expectation, the LOLE value has significantly dropped down from 0.7 to 0.3 here. Yep. Then finally onto scenario 3. Like we've discussed, the base portfolio has a surplus. So the LOLE, it had 12 events, and the LOLE was 0.024. Once you tune that to like 50 events by removing imports of about 1,810 megawatts, and that defines the surplus for this portfolio. We are tuned to 0.1, and I think the next slide should have the same heat map for scenario 3A. So once the scenario is tuned to 1 in 10 portfolio, we have 50 events exact, and then that's how the heat map looks like after you remove that excess or surplus import of 1,810 megawatts. Then finally, I think one last slide just wraps up the results. So as you've seen from the results that all our eligible resources are more than sufficient to meet the 0.1 planning target. So without additional shown RA capacity, we've seen risk in those non-summer months in January, February, so October and November. And then, like we've reiterated, or like we've mentioned in the previous slides, we have other resources at our disposal in the event, like of an emergency. Like I think we use up all of the non-RA and all of the others before we reach an emergency. But yeah, we do have other like state-funded programs, also the effective PRM megawatts. I think these all can be used to bridge that gap between like resource procurement and any resource development that shows up in the CAISO markets in the all are eligible list. So yeah, I think this should be my final slide before I hand it over to Mike to go over the midterm and long-term scope and timeline. So do you guys have any questions? If not, I think we could move on to next section.
Not seeing any questions. Oh, we have one question from Neil.
Noah Tom from Middle River. Going back just right before we get to midterm, do you expect for your next iteration to also update the NQC values for 2025 to for this purpose? Because it would then get you to a more apples and apples comparison with what LSEs and everyone's the community is using for RA counting.
Yep, we will go and take a look at that updated NQC list, and more importantly for the non-CPUC jurisdictional LSCs, what they are doing with their resource counting to help it, and for everybody basically. But yeah, we'll take a revised look at that. Thanks. Mike, would you like to go up there?
I'm Mai Wu, and with the modeling team. Sai already complete the year-ahead short-term presentation, so I'm going to present to you the midterm and long-term. Next slide, please. In terms of the midterm and long-term, we are going to switch the gear from Plaxo to servant model, and we are based on not only the existing RA, also will include the authorized procurement, also PSP from CPUC to do the study for 2 years to 4 years, and also to do 5 to 10 years of the study. The law pretty much based on similar to the short-term format. We use the random walk theory and based on historical load pattern, and apply the ratio to the future. For instance, that based on the CEC project for 10 years ahead of the hourly profile to that, and to get the 10 years ahead of the load profile, and also based on similar approach to get wind and solar 500 stochastic profile. And that was the input profile to the simulation. And also next slide, please. And this is the resource portfolio that we pretty much based on the RA existing RA plus that ASP, those authorized procurement, and Diapro will retire, I think, in 2029 and 30. So we're not count there, and those are the resources that we project will be in line during those period of time, and use the servant model to do the study. And next slide, please. So the result will be similar to just now that Sai mentioned about the LOE and also the hour and unserved energy. And in terms of the how many hours of the outage, and also the maximum shortage of that. And also if there's a shortfall, and we are going to calculate how many megawatt of shortfall or how many megawatt of surplus. So that pretty much wrap up my presentation for the future. So do you have any question for me?
We have one question from Perry.
Hey, Perry Servidios. He said, I'm not sure if it's for you, but it's for Kaiso. I see that you're going to switch from using Plexos to ServM when you get to the mid and long term. Can you talk us through why or what additional features you needed or did not need from Plexos? And is that still a decision that you're making or is it finalized?
Yeah, I think that was the finalized. Right now, we already kicking off, I think Paraline is doing, so we start Plexo to do year ahead. And also we use the server model that we already built a model and doing the study to benchmark with 2025 of the studying result and pretty much similar. So then we go ahead, I think, to do the 2 and 5 years and also 10 years of study. Result will be come up pretty much in November or maybe late, earlier December. So we're going to provide those results.
Yeah, Perry, it was more of a model evolution, trying to figure out how storage dispatch was one of the primary considerations when we chose Plexus many years ago. We want to explore another tool, not from a decisional standpoint, but from more a curiosity standpoint and how the different rules, different models produce and assess risk.
Yeah, no, they have different features and you've used Plexos now for the short-term one.
Mm-hmm.
Next time around, when you do the short-term, is that also going to migrate to ServM?
Nope, it'll always be
Okay, that'll
Plexus.
always be
Yeah, we did not
Plexos.
get a project, we did not get a license to ServM. We only got consulting support for them to assess results in ServM for us.
Gotcha. Okay, has there been any thought in the consistency between the results of these two models? I know you're looking at two different time periods here, but I've just seen in the past that even running trying to simulate the same thing.
Yeah, we are
and both would
benchmarking
give
25.
Yeah, you are
Yeah,
benchmarking.
as
Okay.
Mike mentioned. So
Okay.
We already benchmark, I think, 25 result right now, so pretty much close. So that's why once we feel comfortable with 25 result, that based on Plexo, we have one result. And also based on server model, we have another result, and both results were similar. Of course, not exactly the same, but at the same level. So once we feel confident and go ahead to do the thing that the.
Yeah, thanks for that. That's what I was after. Okay, thanks.
thanks. I also wanted to ask, now that we have already 2 minutes past, can you all stay for another 10 minutes to wrap it up? Sweet, thanks.
Thank you.
Thank you, Mike.
We can hand it over to Aditya next for next steps.
Yeah, thanks. So can we go to the next slide, please? And next one after that. Yep, this is a philosophical statement, right? We all have a shared responsibility to anticipate and prepare for the changing electric grid. Default counting rules and default PRM are outdated. That's what we are trying to figure out, how to work and how to make those updates to the tariff to reflect those. What we've identified in scenarios 1, 2, 3, 3A is having increased KISO visibility of the available resources can help improve grid reliability in terms of knowing exactly how much is available to the grid at what periods in time. Now that we are thinking through the various processes of the RA program at the ISO, this might help offer some more visibility, some more guidance into how we should think about it. Having all resources, for example, shown is one approach to the ISO in the traditional sense of shown. Then you can get rid of outages, outage substitution, and work on UCAP for in lieu of RAIM. So there are design choices that can be informed, but one thing that we are trying to realize from these results is you can come up with portfolios that meet the RA requirements, but it will always help to have full or more visibility to the grid from operating conditions. The last point is longer study horizons are important, as that will help enhance CAISO and LRA's awareness for future vulnerabilities and help to prepare them. Next slide is showing you the path. We are here today at the red asterisk. We looked at the different LOLE portfolios. We've committed to make some look at the 2025 NQC lists for NQC values there. We will look at the outage rates at a high level, for example, and then rerun the scenario 3 if necessary, and 3 and 3A. Once we get to that portfolio, we will spend some time in November after receiving feedback on what resource accreditation we should look for in the default accounting rules and the PRM. Is it something like PCAP, something like UCAP, something based on ICAP is one thing, something based on ELCCs for all resource types, or only for renewables, and UCAP for thermal. So there are multiple ways of counting these resources, and each result in a different PRM. So that trying to get some questions and via feedback to get information on what you guys are leaning towards. The second is how often should the planning reserve margin be updated? Should it be a peak hour program or another program? Like mine mentioned, monthly pre-PRMs or single annual PRM for default. Should the default come with an energy sufficiency check or a requirement to look at 24-hour availability for the peak day? So there are many questions for us to explore in default. We also probably should spend some time in figuring out what the principles should be. It should be easy to apply. It should be consistent. It should be almost not swinging a year from year, and then you can't 1 year you can't say 12 and the other year it goes 24 based on your methodology. So there should be some pattern of consistency and all of that from a principle standpoint. But regardless, those are the topics that we will discuss in the future. Next slide gives us the list of questions that we've asked it's already in the comment tool, I suppose, Christina. Yep, and then they should be available. So we would like to get your thoughts on these questions specifically. But if you have anything in addition to this, please feel free to reach out to any of us here at the ISO. We'll be happy to help answer those questions. Would be nice to get, I'm not telling you how you should provide your feedback, but it'll be nice to get the first sentence in bold that tells you what you want us to do, and then supporting information that supports that point. So it's easy when you read through hundreds of comments. I don't want to miss anything inadvertently. Next slide, please. You have until October 29th to provide feedback to us via the commenting tool on the website. The link is shown. We are happy to sit down with you guys to talk some more if interested. Let us know.
Did you? I said November 4th, I think, or 6th. Is it possible for your team to do 4 weeks? I know that you want to have time to prepare for the
Oh, I thought this was
17th.
November 4th. Yeah, we could update that.
It looks like the 5th would be 4 weeks out. Yeah.
Yeah, 5th is
Okay.
fine.
Okay. That's
right. Oh, yeah, that's true. Yeah, 5th is okay.
Thank you. So we'll get that updated to November 5th for the comment.
And yeah, we are available for happy hours, no office hours. Just kidding. Yeah, we are planning for a follow-up stakeholder meeting on November 19th. Hopefully we'll have our midterm and long-term results, and we'll probably also share the 2025 benchmark of 2 different tools, so we understand what reliability assessment in 2 different tools is looking like. And Ansel mentioned that the policy issue papers are being finalized for posting, and they should be will be subject of a future workshop where we'll think about these things. So I think that wraps up the prepared material for today. And thank you so much for your engagement and a lot of questions. Hopefully, this is the first good step in understanding BA reliability. And thanks. Yes, Noah.
Noah Tom from Middleware Power. Can there be a feedback loop with the ISO for purposes of the short-term study for the next iteration, as well as the inputs and assumptions document? It'd be great to get a sort of maybe like a results document as well, not just the slide deck.
A report, you mean? Results, kind of?
I mean, I don't want to put words in your mouth.
Yeah. Yeah, we could probably. Yeah, but I think, yeah, we could put a few pages of report that shows how the scenario 3 looks. I don't want to get into too many scenarios, but that is basically for us to understand how the changing landscape and what from the ISO lens it is looking like, right? So default rule standpoint, we look at 3A, and we could give you a report of that.
Yeah, I mean, we'll put this in comments, but I'm still not under the impression that 3A gets us to the default PRM value that we're looking for.
Okay, we can talk about it, but yeah.
Yeah, and then again, so an updated inputs and assumptions after stakeholder feedback, so that we all kind of understand where the ISO is going forward with, as well in its next iteration for the short-term study. And would be great to get maybe posting of said documents prior, like maybe a week prior to the meeting, so that we're all kind of prepared and not trying to digest this information on the fly. It'd be helpful.
This is my doing this time. So we were ready a few days ago. We were trying to make sure that some sensitivities were run before it is. And I was telling Kerry this, we didn't want to have multiple versions and different numbers floating around. And then we didn't want to leave blanks and then result in curiosity. It was like better late, but just one slide deck. So no, I totally agree. If I was a stakeholder, I would like to see things at least 3-4 days in advance of the workshop. I promise I will miss the November deadline too, because it's very close. It's November 4th. Yeah, but Thanksgiving and then Christmas and stuff. So we'll see what happens, but yeah, we can hit that. We are very cognizant of that. We only take it. All right. Anything else from this side, that side, on the web? All right. Hearing
I'm not
none.
seeing any questions.
Thank you very much. Back to you, Christina.
Thanks, Aditya. And with that, we'd like to thank you so much for joining today's discussion. As a reminder, this meeting was recorded for informational and convenience purposes only. The video file will be posted on the initiative webpage. We thank you very much, and we hope you have a wonderful rest of your day.